Hey guys, welcome to this session by Intellipaat. In this session, we are going to completely learn about JavaScript. So JavaScript is a language which can be used to create dynamic web pages and also can be used for backend programming. So when it comes to web development, JavaScript is the complete package. So now, before moving on to this session, please subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. Before moving on to this session, let's take a quick glance at the agenda. We'll start off with what is JavaScript and why do we need it. Once that is done, we'll understand what can we build using JavaScript. After that, we'll understand the basic concepts in JavaScript and also the ES6 features of JavaScript. Once that is done, we'll move on to document object model and JavaScript events. After that, we'll move on to asynchronous JavaScript and we'll learn more about it. Once all that is done, we'll basically learn about a popular JavaScript framework called NodeJS. So now once all the concepts are done, we'll start the practical where we'll be doing a hands-on where we create a sample application using JavaScript. So that's it for the agenda. Now without any further ado, let's begin with this session.
Now let us take a look at what is JavaScript. It is important to understand what JavaScript is and how it can benefit us, mainly because JavaScript's meaning has evolved from time to time. Before the current versions of JavaScript rolled out, JavaScript was only used for web browsers, but now it can be used in different ways. So let us take a look at what it actually means. JavaScript is a high-level, object-oriented scripting language. It was created by Bernard Ike in Netscape in 1995. So JavaScript was originally created in 1995. Now, high-level, object-oriented and scripting language are sometimes considered to be a bit more jargonistic than they need to be. Let us discuss them one by one. First thing is high-level. So a high-level programming language is basically a programming language that does not deal with the low-level memory management stuff that other programs might have to deal with. This is because JavaScript has a runtime environment, and what it does is that it takes a look at the code that you have written, takes a look at the memory that it will need, allocates that memory and continuously at regular intervals of time keeps checking if there is some memory that can be freed up. And if it can be, then it frees up that memory, and all of the variables that were assigned in that memory are going to be completely wiped off. So it will allocate and deallocate memory on its own. That doesn't necessarily mean that you have just no control over how things are happening behind the scenes and how that you don't need to care about memory management at all. But at smaller level to medium level applications, you don't really have to worry about how applications are being built and how they are going to be used. At a large scale application such as a large scale JavaScript application such as Gmail or Google Drive, you have to worry about how memory is being used and you have to be very efficient about it. There are certain things that you can do in order to affect how the memory management is going to take place and if it's effective or not. So you can talk about this and discuss about this at length, but that's basically what high level means, that at the beginning you don't need to worry about how to allocate and deallocate memory. Whereas in programming languages like C++, you would have to do the memory management stuff on your own. You would have to allocate a chunk of memory to your program. When that program or that piece of program that executes is done, you need to then deallocate that memory. If you do not, then that memory is going to be reserved and is not going to be used by your program or by any other program because the compiler has not freed up the memory. So just keep that in mind. It's also object-oriented. Object orientation is basically a paradigm of programming in which you write code so that your code can reflect real-world objects and scenarios such as people, person, events, things like that. This is really important because in enterprise-level applications, when you're building applications for companies, the common language that you use are going to be to describe these things. In programming, however, these things are not really something that people consider. So you can create your own objects, you can create your own nomenclatures and translate them into code. This is what object-oriented programming allows us to do. And it's a scripting language because it was developed in order to write and to be written and be executed by the browser. Scripting languages are executed by some other programs, not by the operating system itself. So if you are trying to write JavaScript in the browser, then it's a script, not a program. However, it's very important to understand that JavaScript has now evolved and now it can be used to build other kinds of applications as well. So when it started out, JavaScript was a very simple scripting language that was developed in order to for the sole purpose of manipulating web pages, adding content, removing content, animating things into the frame, animating things out of the frame, changing the styles and whatever. Nowadays, because JavaScript is so popular and so easy to pick up, many of the programming languages many of the paradigms and platforms support JavaScript. You can build JavaScript. You can use JavaScript to build mobile applications, servers, program web servers. Web applications are already being developed using JavaScript, and there are many other kinds of things as well, such as native Windows applications and all. So you can use JavaScript to build different kinds of applications. It has been supported on multiple platforms and will continue to expand its support. So with that, we have a clear picture of what JavaScript is. Now let us take a look at how you can use JavaScript. In this presentation, we'll be taking a look at how you can use JavaScript in a web browser. There are multiple ways of doing so. However, JavaScript, as we have discussed, can be used to build different kinds of applications, and we won't be discussing it here. With that out of the way, let's take a look at how you can use JavaScript. So there are three ways to use JavaScript, especially in the browser. So in the browser, you are supposed to write the JavaScript code in the HTML file or some other file and embed it. But how do you do that? Let's get started and see how you can do that. The first thing you have to understand is that the reason why there are so many ways of writing JavaScript depends on what kind of code are you writing. And in the hands-on for this topic, we'll discuss what that actually means. So the first thing is that it can be inline. Basically suggests that the code that you're writing is completely embedded in the HTML. So if you have a button, it is right next to the button and it's only regarding that button that the code is going to run. So that's one way of doing it. The reason why inline code was invented was that if you had some small bit of code that only needs to run on a particular time or at a particular time, or when it is associated to a particular HTML element, then you can just write it there. Instead of polluting your HTML with different kinds of things, you can just write it there. Then there's script tag. So script tag basically means that there, just as an HTML, there's a style tag in which you can write CSS. Script tags allow you to write JavaScript code. When the browser sees the script tag, it will take anything written inside the script tag, which is the opening and closing tag, and consider it to be, depending on the version of your browser and what kind of support it provides. So in scenarios like this, we would have to write some kind of a text that describes what kind of script we are writing inside the tags, such as text/JavaScript or whatever. Nowadays, it is considered that by default, you're going to be writing JavaScript in the script tag. So you don't have to worry about that at all. Then comes script files. Similarly to script tag, you can write your script inside a file, give it the .js extension, which is the JavaScript file, and you can embed it inside your browser. So you are going to say, okay, after you're done loading the HTML page, load this file as well. This file contains some HTML code, and this file contains some JavaScript code that needs to be embedded in the HTML file. Now, the reasons for the different kinds of script files is something we'll see in the hands-on, but basically it depends on how much of the entire HTML page is going to be affected by the JavaScript. So let's take a look at the hands-on and understand how that works. How you can write the JavaScript code. We'll be printing something on the console. I'll explain what a console is, but first let's see our setup. I have a file, I've called it index.html, and I have opened it in a code editor. I'm using Visual Studio Code. You can use any code editor or text editor that you wish to use. Open that file inside a web browser. My file is located in the E drive and it's called index.html, but you can call it anything that you want to. It's just a convention. Now let's take a look at the different ways that we have discussed using which we can create our JavaScript code and embed it inside our HTML. The first thing we have to do is we have to write some HTML code. Now in Visual Studio Code, I have a snippet that will automatically write most of the HTML that we need in order to get started. So just press this bang symbol and press tab. This will only work in Visual Studio Code. If you're using any other programming environment, this may or may not be available there. So just make sure that you know that it is there. I'll call the title to be JS Tutorial I will save it. And now if I go back to the browser and if I refresh, if you take a look at the title right now, it's index.html. Refresh it. Now it's called JS tutorial. So in case you're not familiar with HTML that much, I would recommend that you first understand HTML because JavaScript builds on top of HTML. So if you don't know HTML, then this is not going to work. Now let's take a look at the different ways through which we can use the JavaScript code. So there are different ways. Firstly, that's the inline code. So how do you write code that executes inline? Well, let's say there's a button. I call it log button. And what I want is when this button is clicked, I want to print something on the console. Now, what is the console? Different programming languages such as JavaScript and C++ have a console. Now, a console is basically just a terminal or a command window which will show the output of the code that you're writing. You can also put the output inside a file or inside some server, but basically this is where the output can be seen. Now, in a web browser, it's a little difficult. So what every web browser has is a JavaScript console. Right click on the web browser and click on the inspect button or press Ctrl Shift I. Nowadays, every web browser has this. When this opens, you can see that it has a console button here. I go up to that and I can execute my JavaScript here as well. To print something on the console, you can just execute some JavaScript code here as well. I can write console.log and I'm using Google Chrome, but you can use any web browser such as Firefox or the Edge browser using Microsoft and it will work just fine. And you can write hello world. Semicolons are not required, but it is a good practice to write them. You press enter and this is what it prints. Hello world. Forget about this undefined right now, that doesn't really matter. Now what I want is I want this to be a little more interactive. To do that, I want to have a button which has the keyword log inside it. So if I refresh this, you can see there's a button, but nothing happens when I click on it. So that's a problem. Now I want to execute the same code that I have written in the console, but I want it to happen when I click on the button. So don't worry about the syntax right now. I'll explain what that means in a moment. Just write this JavaScript hello world, and I can put the semicolon here as well. I go back. If I click, nothing will happen. This is because our browser has the old version of our index.html. We have to refresh it so that we can fetch the new version. To take a look at the current code, right click on the page and press view page source. As you can see that the button now has console.log because it has refreshed. If I refresh this, now everything will work. If I press log now, it prints hello world onto the code. Now, as I've already discussed, the reason why there are multiple ways of doing this is because I only want to run this code when a person clicks the button. Suppose that there are multiple buttons on my page. It's a huge page. There's like thousands of lines of code. And somewhere down the line, or like 1157 line, I write button and I want the same code here. One thing I can do is copy and paste it here, such as this. But this violates an important principle in programming, which suggests that you should never copy and paste the code. So console.log, console.log. It does work, but there's a problem here that you may or may not see. Suppose that this is like, again, as I've said, it's on 1000 line. Multiple people are working on this because this is such a huge file. Somebody comes along and says, okay, the message that we want to print is hello world, but we want an exclamation mark here as well. I put the exclamation mark, I save it, go back to my HTML page, refresh it so that I can see, press on the log button, and okay, it's showing the exclamation mark. So our code works, but the problem is now that the part where we copied the code, it's showing the old version because we didn't update it there. So now we have to go down again and press this, and this is only for two buttons. Suppose there are millions of buttons on a page. Suppose there are buttons and forms and we want to perform these tasks, multiple tasks, and synchronize them together. This could be really difficult. Right now it's working, but it's going to be really difficult. There are other ways of doing this, of course, and we will take a look at those one by one. But to overcome these issues, let me just close this up. Yeah, so I'll just put an h1 tag, look inside console. Now let me just show you what a script tag looks like. So after this, I can write script tag, and here I can write my JavaScript code and it will work just fine. This time it won't work when I'm pressing a button. That was just for the inline version. Here I can just write some code that will be automatically used. So as you can see, as soon as my browser starts looking at the code, it takes a look at the code, creates the h1 tag, displays it on the screen. Then takes a look at the script tag. What it does is that it prints everything that needs to be printed on the screen and then closes the script tag. So everything after this needs to be interpreted as HTML, and that happens. So this is why when we look at this gets printed and then this gets printed in the console. So that's one way of doing this. Another thing to understand is that this isn't the only way that you can do this, but this is a good way to get started. Another way to do this is going to be if you can create a script file. So now script files are basically just files that you can use in order to write your code inside them. So you don't want to mismatch your HTML and JavaScript code. What you can do is you can just use script.js. Now to show you how that works, all I'm going to do is I'm going to open up a script.js file that I have already written. I'll write console.log. I'll print hello world. It's the same code that I have written thus far, but it works. Now I write it here, copy, paste, save. If I remove this now and I'll just keep it here. Now do you think it will work? Not exactly, because our HTML page has no idea that the script tag exists. So inside the script tag, I have to write another attribute called source, and the source file is going to have a name of script.js. Save this, run this again, and now it works. So now what happens is it takes a look at the entire web page, takes a look at the h1 tag, displays it on the screen, takes a look at the script file, opens up the script file, executes the code inside it, comes back, closes the script tag, closes the body, closes the HTML, and is done with it. Now the reason the script files were invented so that because we may have multiple web pages. So it's not that we only use one page. We could have about.html and many different kinds of files, and we want some file to have access to all these pages. So in cases like this, if I have an about.html, I can just copy and paste this script tag, and that code will be available inside that file as well. So when that file is loaded, it will be logged on the console as well. And if it's like 10 different files, all I have to do is just change it here. If I want to make another change like this, and all of this will be reflected in all the files. So that's the reason why we do it this way. Now, again, this is not the only way to do it. As we have discussed, 3 ways you can work them out and understand how to use them. Very much like CSS, in which you have inline styles, file level styles, and then external styles in which you can create your own CSS files. Script tags works the same. In other versions, because script files could be so heavy, let's say that you have 7 different script files, then it could be possible to just merge them all into a single file. This is called a build step, and you don't need to worry about it right now. But basically, in cases like this, all of the JavaScript code that you write is taken and merged into a single file by a program called a build system that you can configure yourself. And then it creates that single file so that when an HTTP request is sent, only one file is sent over the wire and multiple requests are not done. So you can take a look at that as well. But these are the ways that you can configure a JavaScript file to work with your HTML page. Again, you need to know HTML in order to work with JavaScript because that's how it was created. So that's how you can get started with it. Alright guys, now let's take a look at what can you build with JavaScript. So we have discussed thus far what are the different ways that you can use JavaScript and what JavaScript is. But now let's take a look at what it can be used to build. So using JavaScript to build different kinds of applications has been the norm. Many different companies use JavaScript for different kinds of applications that they build and use. Let's take a look at what these are. So JavaScript can be used different kinds of applications. These are web applications, web servers, native mobile applications, and hybrid mobile applications. All of these have different ways of being used, and different JavaScript code can be used to use it. So let's take a look at them one by one and demystify how these things work. So the first thing is web applications. Using JavaScript to build web applications has been the norm. We have been building web applications using JavaScript since the invention of JavaScript. Now, the reason why it's so popular nowadays is because there are multiple ways of building a web application using JavaScript. The easiest and the most fundamental way is the way that we have discussed thus far, in which you create an HTML page, write the HTML code, embed some JavaScript in it, either using inline JavaScript or script tags or script files, and then that code is going to be used to manipulate the JavaScript, manipulate the HTML page using the JavaScript in some way or the other. Now, this manipulation can be of several ways. Either you add some element on the node, remove some element on the node, get some data from a web server, and after getting that data, populate the entire HTML page with some new content that is available, let the user know that some new content is available, and many different kinds of things. Now, that is important and very, very useful, but that's not the only way that you can do it. The other way is using something called single page applications, in which there's just one HTML page, which is used to just give the basic scaffolding and the shell of a page. Outside that, we have a JavaScript page that takes care of everything else. So if you've heard of frameworks such as Angular, Vue, React, they work on the similar premise. What happens is your HTML code is very minimalistic, and it is a big fat JavaScript file that is transferred over the internet. Once the user's browser has that JavaScript, it tries to execute it. When it's executing it's creating multiple HTML nodes using JavaScript, putting it inside the HTML page, and then JavaScript takes care of everything else. Navigation, HTTP calls, manipulation of the DOM, any kind of thing that a web application is supposed to do, JavaScript will take care of it. These applications are really JavaScript rich, and HTML is really used as a skeleton. Not much of HTML is used. CSS is used throughout, and it will be continued to use throughout, but that's the way it works. So because of this fundamental shift in how web applications work, the responsibilities of web servers have changed. So let's take a look at how you can use JavaScript to build web servers. Now, what used to happen before we had platforms like NodeJS, which we can use to build web servers, which we'll also cover in this tutorial. But the reason why web servers were a little difficult, especially for front-end developers to understand, is because of the language barrier. So in JavaScript, in the front-end web applications, we'll be using JavaScript all the way. And since that was the only language that we would use to manipulate the web applications and its structure, but in web servers, you can build a web server using different kinds of technologies. JavaScript was not one of them. So the way you would use it would be using technologies such as PHP, which is still by far the most popular server-side scripting language. Then there's Java, which is very popular in the enterprise world. So is C# and the .NET platform. There are other languages such as Ruby and Python that were used, but JavaScript was not really a big player in that regard. So what happened afterwards is that we had the introduction of the Node.js platform that allows us to write JavaScript code so that front-end developers can sort of port their expertise to the backend. Now, it's important to understand that just because you can write JavaScript code on the web server or write the code to create a web server, that doesn't necessarily mean that you can just copy and paste your entire JavaScript file from the web browser to the web server and it will work exactly fine. Mainly because these are two different environments. In the browser, you will have elements such as a button, you will have elements such as a form, list, and whatever. It's a very visual environment. In servers, you don't have that. You have number crunching and different kinds of things such as accessing databases, caching data, serving up data, and whatever. So these are two different environments, although you can use the same JavaScript syntax, for loops, console logging, promises, and all the features. But you can't just port the code from here to there, just copy and paste, and it will work. So that's something to keep in mind. Now, in web servers, we use Node.js. Node.js has come a long way. We have Express.js, which is one of the most popular frameworks out there. Node.js is really popular among enterprise as well. And any kind of application that you want to build using backend development, Node.js is very much likely a good option to do that. Then comes native mobile applications. Now, the reason why we are making a distinction here between native and hybrid mobile application is something that we'll discuss in a moment. But the reason why we are saying that we can build native mobile applications is because before this, if you wanted to build an application that your customers could use, you had multiple platforms that you needed to tackle. Platforms such as Android, iOS, Windows Phone, and some other platforms as well. This was a bit problematic because then that means that if you want your application to be accessed by a large number of users, you need to write code for both Android platform as well as iOS platform. These two platforms have different programming language, different programming structure, different skill sets, and different environments in which you can develop applications. Android is open source, so you can build Android applications in both Mac and Windows. However, Apple doesn't allow you to build iOS applications on a Windows laptop. So you need to have a developer account, you need to have a Macintosh laptop, you need to have developer tools installed, you need to have an iPhone to test your applications. There's just a lot of upfront capital required there. In Android, you have the emulator, you have the open source tools and everything. But still, the languages are different. JavaScript is not really the language that they use, but they use Java in Android. And in iOS, the new language that is being used is Swift. And in Android, the new language that is being used is Kotlin. And the previous language in iOS was Objective-C. None of these languages are easy to pick up. And because JavaScript is so easy to pick up, more people know JavaScript than they know Java or Swift or Kotlin or whatever. Now, this is a problem mainly because the web applications that people build almost exactly mimic the features that we would want in an application, in a native mobile application. Now, there are ways through which you can use your current web application and have it work as sort of a substitute application inside your mobile applications. But the problem is that at the end of the day is using the web browser. So what happens is your web page is loaded into a web browser and it takes care of everything using JavaScript. Your application has no access to all the underlying features such as the camera, the machine learning features that have been developed, the Bluetooth, speakers, OS, internal hardwares, voice recorders. You have no access to them at all. So if you're trying to build a camera application, you can't do it using JavaScript, or you couldn't have done it. Nowadays, there are frameworks such as React Native, NativeScript, and many other kinds of platforms available where you can use your JavaScript skills in order to build native mobile applications. Again, it's not as simple as just copying your JavaScript code from your web application or your server application into a native mobile application. However, it is very similar to not learning a new language, but understanding the ins and outs of a platform and then adding your skill set on top of it. These applications are really native mobile applications, and the great part is that when you write the code, that code will get converted to both an iOS application and the Android application. You would still need to have the developer account, and for testing purposes, you would need to have access to an emulator or a Macintosh OS in iOS's case or whatever. But you can still have an application that will work. So that's the great part here. So this is what native mobile applications do, but still it needs a lot of configuration and understanding of the platform before you can even start building an application for the platform. On the other hand, we have hybrid mobile applications. Now this is a solution that has been available for a long time. What it allows you to do is it allows you to write JavaScript, and that JavaScript will then get converted into native OS calls. But this is a little slower than native mobile applications. If you're building applications that are just there to deliver content, such as an application that is there to tell people about the new concerts that a band is going to have, new conferences available, new videos available on a video store or whatever, then hybrid mobile applications are good. Native mobile applications, on the other hand, if you want to access the native features such as camera, browser features, voice recorder, Bluetooth, gyrometer, sensors, infrared, whatever your application has to, whatever your mobile has to offer. So hybrid mobile applications use platforms such as Apache's Cordova, and many other new platforms are available as well. You can take a look at these platforms and build these applications yourself. It's not very difficult to learn how to build these applications, but these are really helpful for us to use, and they're very easy to use as well. So these are some of the platforms that can be used. You can also build native Windows applications. You can also build native desktop applications using a platform called Electron, which was developed by GitHub. And there are many others as well. It is too much to count. But these are the platforms that are used. As you can see, JavaScript has evolved from a very simple programming or scripting language that was used to manipulate web pages to a full-fledged application programming language in which you can build applications of multiple kinds. Kind of like Python, but a little different. You can also write machine learning and AI code, but that's a whole different topic on its own. So that's how you can build applications. These are the kinds of applications you can build using JavaScript. This is exactly why JavaScript is one of the most popular job positions right nowadays. JavaScript developers are in high demand because they can use their skills or already existing skills and learn some new skills in order to build many kinds of applications. So with that in mind, let's see what else we can learn.
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which of the following is not considered as an error in JavaScript? A. Syntax error. B. Missing of semicolons. C. Division of 0. D. Missing of brackets. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now we'll take a look at the basics of JavaScript. JavaScript as a language has several features that we can learn in order to get started with the basic concepts of programming. If you've never learned how to code, then you can follow along with us. This section is going to be really hands-on focused. So we'll have a lots of hands-on. We'll discuss a lot of caveats that you can learn when trying to learn a programming language. If you have already learned some basics of some programming language such as Python, C++, Java, it's going to be useful for you to follow along with us so that you can understand what are the features and differences between JavaScript and the language that you have learned. So firstly, we need to get comfortable with the JavaScript syntax and language features. So how does JavaScript work? What are the features that a JavaScript program would have, and how you can write programs on your own? The topics mentioned below are the topics that we'll be covering one by one. We'll have a hands-on for each one of those, and we would like for you to follow along with us. You don't need much of setup. All you need is a web browser, a code editor, or a text editor of any sort, such as Notepad if you don't have any, or Visual Studio Code, or you can use other code editors such as Sublime Text, Atom, Brackets, and any other kind of text editor that you prefer. And for that, we'll go through each of the topics one by one, and we'll cover as much ground as we possibly can. So let's get started with this. The first thing is variables. Now, in case you have programmed before, you already know what a variable is. But if you don't know, let me just clarify this for you. A variable is basically a name given to a memory location in which we can hold some data. That's basically all that is. So if you want to get as an input a user's username and password, you can store them inside a variable. That variable is then going to take care of everything that you store inside it. So we have a container. That container has a name. That name is then going to be used to reference to whatever value we put inside it. Think of it like a bucket inside a memory. Think of a memory as this empty room. We have a bucket. We put it with a name on that bucket. We put it inside the room. And in the room, inside the bucket, we put some information, something. Let's say that I want the username. So I create a bucket named username, put it inside the memory, and now whenever I want to use a person's username, I would first ask them, okay, enter a username. That person will enter the username. That username that the user entered will be put inside the bucket. And now whenever I want to access or remember what the username that the user had entered was, we'll take a look at that. So that's how variables work. Variables allow us to store data. Now it's called a variable because the data inside it can change at any time. It's variable depending on what is the last bit of information you put inside it. So that's the way it works. It allows us to store and remember data that we would need in a future computation or a future process. Now, variables store data in computer's memory or your system's memory. That means that they are volatile. So in case your program accidentally closes, anything that was stored inside a variable will be lost. If you don't want to lose it, then there are ways that you can store it inside a file or whatever. We're not going to be covering that, but that's how variables work. The data that you have inside a variable can then be stored inside a file, on a web server, on other data storage platforms as well. But as of now, when you're using a variable, we're talking about data inside a memory that was given a name so that it can be accessed later. The data inside the memory location can change. That's why it's called a variable. All right. So now let's take a look at a hands-on in which we'll be learning variables. So we would very much like you to follow along with us in this hands-on, and we will cover variables in this hands-on. Again, you don't need much. All you need is a code editor. I'll be using Visual Studio Code, and you need a web browser. In the web browser, just any web browser that you use the same setup that we had earlier, in which we had created an index.html file. Open that up in the web browser and in the code editor, so that when you make changes to the code, you can refresh the browser and see the changes being reflected here. Open up the console as well, because this is where we'll be using the web browser. This is what we'll be using inside the web browser as of now. So again, I will just use the script tag so that I can just embed my code here. But the basic understanding here is quite simple. The code that we're writing is JavaScript, and we want some input from the user. Now, I will tell you how you can get input from the user in a moment. Right now, let's take a look at how you can declare a variable. So in a variable, there are multiple ways of doing with things. First thing I'd like to show you is how you can write a comment. Comment is basically something that you write that you want the person who's reading the code to be able to understand, but you don't want your browser to interpret that code. You're basically saying this is something that is not code, that is just something that a person who's reading the code is supposed to get. You don't have to worry about it. Don't interpret it. This is not code. Just move along and skip this line. So there are two ways of writing a comment. One is you can use two forward slashes or the division symbol, and that is a single line comment. So single line comment. Let me just change the theme so that it's a little more apparent. Yeah, hopefully this is visible now. So I have a single line comment, and now I can have a multi-line comment as well. This is what happens when you have a divide symbol followed by an asterisk or a multiplication symbol, and this closes when you have a multiplication symbol and a division symbol. So start and the end. So the way you start it is this. You basically just create this symbol, and then you write the code that you want, or write the things that you want to write. So this code is using a variable, and I can write it in a new line. Variables are being used, or whatever you wish to write. This is to explain the code so that the person who's looking at the code can understand what it is doing. Now, a single line comment is good if you just have a single line description. If you have a multi-line description, then you can have a multi-line comment, right? So now let's show you about the three things that we need. So there are three things that we need to understand. First is declaration, and second is after declaring the variable, we use the variable, or you can also call it initialization, and the third one is using the variable. So the way it works is this. To declare a variable in JavaScript, you are likely to use a keyword called var, var. Var is a keyword that was developed in JavaScript so that you can use variable of any kind. If you come with other programming languages, then you would have to use the keywords such as int, string, or whatever to describe the type of language. Here you just need to use the var. And now I need the name of the variable. Let's say user name. And this is what is called a declaration. I'm saying, okay, I'm going to be using this variable. Now, JavaScript to a certain degree is a very relaxed language. So even if I were to not use the var keyword and say hello, and then console dot log the username, it will still work. It might throw an error, but it will still work. So it doesn't even throw an error. Now that is a problem that when you're writing the code, there are certain tricks that you can use. One of these is something called use strict, which will work in a JavaScript file. I don't know if it works here or not, but that way it will be very strict in checking whether or not a variable is there. So it says, okay, the username is not defined and you're using it, and it will return an error. So that's one way. Now, if you want to use the username, just use the var keyword. Now it's defined. And if you want to initialize it immediately, initialization basically means assigning a value to the variable. As soon as you're creating a bucket, you're filling the bucket. So you can do it this way. I have it here. I refresh and it works. Even if I were to instruct the browser that be strict and don't allow any problems in my code, it will still work. So that's one way of doing it. Now that's called initialization. That's the second part. Now declaration is this. You just create a variable and you say, okay, I need this bucket. I'll use it later on in my code. I don't need it anywhere else. I just need it right now. Now how you can take the input of the user, there are various ways. One way is using prompt. Now this is only available in web browsers, and this is not used commonly because in web browsers you're not allowed to take users input like this, or you don't usually do. But if you want, you can just prompt the user and say enter username, and whatever username is entered, you can just put it inside username, save it, and then you can print it. So if I go ahead, refresh this, it says enter username. I call it John, press enter, and this is how I can get a user's input in JavaScript. Now again, you don't really need to use it, but you can if you wish to. So that's what declaration and initialization is. And then using a variable is again the simplest thing that you can do is just print it. Now printing is not the only thing you can do. There are several operations which we'll discuss when we're discussing operators. But basically when you're trying to learn a new language, understanding how variables work is really crucial. I can declare multiple variables as well, such as username, and another would be using password. Now I can declare them on the same line if I wish to, or I can declare them on multiple lines like this, so that I use the var keyword again and again, or I can just put it like this. And again, if I had another variable name, I could do the same thing again. But it doesn't matter how you do it. What matters is you're describing some type. We would always recommend that when you start a JavaScript file, you use the use strict declaration, so that when you are using a variable that is not declared, it doesn't become a headache to understand how it works and where things happen and how things happen. So always use this if possible. If you are new and you don't want the safety and instructions, then you can leave it, but we recommend that you keep it here. Now, again, if you're coming from different programming languages, you would think that you would need to describe the kind of data that is going to be stored inside it, but such as a string, integer, or something like that. But that's not really the case. This is called a loosely typed language or dynamically typed language, in which the type of the data is just something that the language figures out automatically. Data types are still available and we'll discuss them now, but the reason why they are not available in the same way in other languages is because in JavaScript everything is loosely typed. So if you have data in one language, one type, and you want to convert it to other type, you can do so quite easily. Let's discuss this now. Let me just save this up and let's see what else we get. Alright guys, now let's take a look at data types. So as we discussed that there is a way for us to get data from the users and put that data inside a variable. That variable is something that we can use later on. So for instance, we took a user's username as some information using the prompt function. Now that's not the only way that you can take data. In fact, in a web browser, you usually don't take data like that. You use a form that the user will submit, and you will then get that data and put it inside your web browser's memory, and that's where you use it. Now the real issue here is that something we haven't quite touched on thus far, which is data types. So as you can see, that data is of different type. One, the username, that could be a long string of text, long line of characters, one after the other. The other is numeric data. So you're asking for a person's age, their salary, their height. All of this is numeric information. Then there are other kinds of things such as true or false. So if you're asking a person if they are above the age of 18 or not, if they are senior citizens, you can get this information simply by taking a look at their age and determining if it's above certain threshold. But there are certain instances where you don't want that information. You just want to know if they are above the age, if they are senior citizens in their own country. That's another way. And so many different kinds of data. So what does that tell us about the languages that we use? Well, one thing to understand is that different data have different operations available to them. So if I have a number and I say, okay, I have 5, multiply it by 10. That makes perfect sense because multiplication is an operation that can be performed on numbers. Now, if I were to take a look at some other kind of information, such as if I were to say, okay, I have a username, multiply it by 10. You're not going to make any sense of that because it doesn't make sense of multiplying a name by some number. It makes no sense to do that. So your browser is going to complain, your program is going to complain saying, I don't know what you're asking me to do because this is not how this works. Now, how does the browser or the language know what kind of data is stored inside a variable? Is it a number? Is it a long text? Is it some binary information such as true or false or something like that? This is done using data types. Now, data types are of many types. We'll discuss them when we're looking at the hands-on. In JavaScript, there are many kinds of data types, and in many other languages also there are many kinds of data types available as well. So this is the way we use the data types that we have. Data types allow the compiler or the interpreter, when it's interpreting the code, to understand if a particular operation is legal or not. This is the most important aspect when we're learning something. So let's take a look at a hands-on and figure out how this works. Now let's have a hands-on in which we'll discuss the different kinds of data types that are available for us. So For that, all you would have to do is just follow along with us. Open up a web browser, same as before, and open up the text editor. You might also not need the text editor right now because we'll just be writing it in the console, but it's a good practice. So I want to declare a variable x is equals to 1. Now, this is obviously a number, but if you want to take a look at the data type of a number, you can use the type of keyword and type the name of a variable that is available next. So x, it will give you number. So it indicates that it contains a number. Now, even if I would just write the value here, it will work just fine. Even if it was a fraction, this would work. Any other kind of value would work. So that's a number. Numbers are quite self-explanatory. These are just values that you can use. Similarly in mathematics, the same way that works in mathematics, they will work here.
Okay guys, a quick info. If you're looking for an end-to-end training in JavaScript, Intellipaat provides a full stack web developer course which covers JavaScript and all the JavaScript frameworks you need to know. For more details, check out the description box.
Now we also have the username. Let's enter the username of John. Press enter. If I were to now, let's take a look at the value. Its username is John. And now if I were to take a look at the type of the data, it is string. So string is nothing but just data enclosed within quotes. So even if I were to write one inside quotes, it will be a string. So if I were to do it this way, this is a string. So one thing to understand is that it doesn't necessarily have to be double quotes. As you can see here, let me just expand this up. It doesn't have to be double quotes like this. They can also be single quotes like this. And this is also a string. Here you go. Empty double quotes and empty single quotes are string. Anything within a double quote is a string. Anything within a single quotes is a string. So if I want 1, 2, 5, 7, 6, 1, 5, 4, 8, these are numbers, but these are strings. If I were to remove this, then this becomes a number. Now, the other thing to understand is that even if we have strings like this, the important aspect of the strings is that they are just a collection of characters. So that's the way it works. But if you want to add some sort of a text inside it, such as, let me just show you. Now, if I were to write, okay, John said, let me just, John said, and now if I want to quote it, I can't use double quotes, as you can see here. This will give me an incorrect syntax and I'll get an error. So if you have started a string with double quotes, if you want to add more quotes inside it, you can use single quotes. So just this, John said he's not coming. So that's a single quote, or he is not coming. You can write it this way, and this is still work. Now, if I were to do it the other way around, if this was a single quote, then also this would not work. So I would have to create a double quote, and this will work. So as you can see, these are how the quotes work. Now, this is called a string. What about values where you just have values such as true or false? So if I want to check, well, if a user enters a username, and if I want to check, well, is the username the same as John? So in cases like this, you get the values such as true or false. These are two values that are used inside JavaScript and many other languages, and it's of type Boolean, type of true, and it's Boolean. So as you can see, this is considered to be Boolean. Now there's another type, undefined. This basically means that the value does not exist. It's not defined. We don't know what the value is. If I were to create a variable, let's say bad, and if I were to type bad, it has no value assigned to it. So right now it's undefined. If I were to check the type of bad, it's undefined. So I can't perform any operations. Now it comes time for operations, and we'll take a look at more of these operations when we're covering operators. But just to give you a quick overview, for X, we have a variable of 1, right? So I can perform for operations such as X plus 1. 1 plus 1 is equal to 2. So what happens is our compiler or our interpreter will take a look at X, see if it already has a variable named X assigned some value to it. It has a variable named X and the value assigned is 1. So it will substitute it for 1. 1 plus 1 equals 2. That works. Now for username, I have John. If I add username plus 1, I'll get this gibberish value in which it just concatenates the word John and 1. So that works. Now if I were to get the bad variable which has no value and I were to press 1, it gives me another return that says not a number. So depending on the kind of value that you have, you will get different output. That's one way. And if I were to use true plus 1 and get enter, you will get 2 because underneath true is represented as 1 and false is represented as 1 as well. So these are the kinds of values that we have, and this is because we have a simple dynamically typed language in JavaScript. It doesn't really matter what kind of variable it is. JavaScript will try to force one variable into another. But if I were to take username and plus undefined, you can see this is what I'm getting. If I were to get variable and press true, this is what I'll get. So this is the problem that we'll face. I will think that I have a number, let's say it's 1, but it's a string. I assign it here and I say x plus y, and let's say y is equal to true. If I don't know the type of the data inside it, I expect it to be this and I get this. Or if I would go x plus 12, instead of getting 2, I'll get 112 in string. That's a real problem. That's how we can understand how this works. And this is why data types are important. Our operations, what operations we can perform is going to be shown here. Similarly, if I had username multiplied by 2, I will get not a number because this makes no sense. I don't know what you're doing. So I'm giving you a result that is not a number. If I were to use not a number and take its, this is really complicated web of how things work. Don't worry about if you don't get it right now. Just understand that there are different kinds of data. Different operations are allowed on different data. So if you have two variables, you're trying to add them, x plus y, but you're getting not a number. That's basically because you have data types of two different types, or you're trying to multiply it and you're getting some other kind of value. Let's say you do this, then you get 0. So this is what happens. If you are finding it a little difficult to wrap your head around, don't worry. Just take a look at the different kinds of data that is available. Now, other kinds of data that is available is arrays and objects, and we'll discuss both of them in a moment. These are containers. They can contain multiple values of different data types, and they can contain the same containers inside them as well. And we'll take a look at that now. So let's take a look at those. Now that we have taken a look at data types and have had a hands-on to understand what different kinds of data types are available, namely string, numbers, boolean, and undefined, let's take a look at what else we can cover. So now we'll cover operators. Operators are basically used to manipulate data available in memory. As we've discussed in the previous hands-on, when you want to add two numbers, you use the plus symbol. That is an operator. Operators are of multiple kinds to perform multiple operations depending on the data type and the data available in them. So we'll take a look at them one by one. But the important bit to understand is that operators need some data. Now you can have operators that are unary, binary, and ternary. Unary operators operate on only one variable or one operand. Operators operate on variables, and those variables or data sets are called operands. So if you only have one variable that can be manipulated with an operator, that's called an unary operator. It only needs one variable to work. We'll take a look at the specific examples of these one by one. Then there's binary operators, which take two operands, and you can use these two operands to use these two operands in order to perform some operation using the operators. Finally, there's the ternary operator, in which you use few symbols in order to operate something. We'll take a look at a ternary operator after we have discussed conditionals, and we'll try and explain what that means so that it's a little clearer for you, because these two things are related. But these are the things that an operator is. So we need to understand what an operator is, which is basically just some symbols that we use in order to manipulate some data that we have available in memory, basically variables. Although these values could also be just the literal values that we see and not some data that we get from the user and store inside a variable. However, that depends on how you wish to use it. So now let's take a look at how you can use operators for your benefit. Now let's take a look at a hands-on in which we'll be taking a look at the different kinds of operators that are available and how you can use those operators in order to work with the data that we have available. So open up the web browser and open up the console so we can just write the code and see it work. Now for this, you don't really need any kind of different environment. You just need a web browser. Let me just create a variable, call it number, and I'll assign a value of 0. The first kind of operator that we'd like to discuss is a unary operator. This operator allows you to increment the value of a number. So if I have a number and I want to increment its value by 1, what I can do is num plus plus. Right now the value of number is 0. I do this, press num, and now the value is 1. This is called a unary operator because I only need one variable for this to work with this operator. Now, it doesn't necessarily mean that I just have to write the plus plus operator right at the end. I can also write it at the beginning, and you'll see a difference here. So earlier the value inside number was 0. I used the plus plus operator. I pressed enter and I got a value of 0 here. Then when I take a look at the numbers, the value inside number, it became 1. Right now the value inside number is 1. I use the increment operator right at the beginning instead of the end, and I press enter. Now I get 2. And now if I take a look at this, I get 2. So what exactly changed here? What happens is, if I want to first access the value of a variable and then increment it, so I will use the plus plus operator at the end. This is called the increment operator. So this is called a postfix because I am using the increment operator after the variable name. So if I wanted to print it and then increment it, so let's say I was going to go like this: console.log number is currently 2 plus plus. Press enter. So I print 2, but now if I take a look at the value, it's 3. Similarly, if I would have gone plus plus num, right now the current value is 3 and it should print 4. So it increments the value and then prints it, and in this case it prints it here, the current value, and then increments it, which is this. So that's the unary operator. You don't really have to worry about it because it's not just increment, you can also decrement it like this. So now we have number 3 here, but if I were to do this, I have 2, and the same thing, the same logic applies here as well. So now that we understand unary operator, let's take a look at a few binary operators as well. This is what we can do in arithmetic. So if you want to perform arithmetic operations such as addition, multiplication, division, even subtraction, and there's a modulo operator as well, and we'll take a look at them now. So if I have two values, let's say var x is equals to 10 and y is equals to 5, and if I want to check x plus y, I can just use the arithmetic operators. As you can see that this requires two values, one on the left hand side, one on the right hand side. This is why it's called a binary operator. Binary means 2. So I get this. Similarly, if I want to subtract 5 from 10, x minus y is going to work. If I want to multiply these two values, I can do that. If I want to divide them, I can do the same here as well. One thing that you can notice is that if I wanted to take a look at the remainder that we get after we divide x and y, we don't get it here. But if I want to get that, I use the modulo operator, which is the percentage symbol. It means divide x and y, whatever remainder is remaining, print it here. Since 5 is perfectly able to divide 10, that means that you don't get any remainder. But if I were to divide 12 by 5, if I were to do that, 12 divided by 5, I'll get 2.4, which means it doesn't perfectly divide 5 and the remainder is 2. That's the way it works. So that's one way of understanding binary operators. These are the arithmetic operators that have been available to us or for us to use in JavaScript. JavaScript doesn't necessarily have just the arithmetic operators. It also has other operators which we'll take a look at now. But it's important to understand that there are these operators are important, and there's operator precedence as well, such as BODMAS. So you can take a look at that if you wish to as well. Then there's the assignment operator, which we have been using so far. So if I have a variable named Z and I assign it 45, this variable or this is an operator, this symbol, that's the equal to symbol. This is called an assignment operator. Now, if I want to assign a new value, I can just use the assignment operator, and this works as well. So that's the assignment operator. Again, it needs two values, so it's a binary operator. And then we have addition and multiplication, which is something we have already taken a look at. Increment and decrement is also something that we have taken a look at. But one thing that we can also take a look at is a shorthand example. So if you are using a variable, let's say x, I will assign a value of 1 here. And what you want to do is you want to increment it by 10. Now x plus plus is only going to increment it by 1. But if you want to add 10 to it, then you have to assign it again. So you have to go, the current value of x should be whatever the value of x is plus 10. So I have 1, which will be substituted here, and plus 10, which is 11. That's one way, but it's a little cumbersome to write x again and again. Now let's say that the name, the value was user's age is 10. So I would have to type the user's age equals to user's age plus 10. It's a little annoying. So another way you can do it is something called a shorthand. You can just use plus equals 10. That says that whatever the value of user is, add 10 to it and then assign it to user's age variable. And that now the user's age is 20. Had I just written user's age plus 10, I would get the new value, but inside the variable, I will still have 20.
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which event can be fired on a scrollable document element? A. Window. B. Scroll. C. Load. D. Unload. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So because I'm not assigned it, I just calculated it and threw away the variable's new value. So that's the shorthand operators. It works with all the operators that we have taken a look at so far, which is the multiplication, division, addition, subtraction, and modulus operators as well. So that works. Another thing is, if I were to do this, this will raise it to a power. This is called double multiplication. So if I have a value, let's say I have 2 raised to the power 10, it's 1024. So you can take a look at that as well. And this also works in the operators. So with that, now we can also take a look at comparison operators. Comparison operators are really important to understand because this will form the foundation of the next topic that we'll understand, which is conditionals. So let's say that I have a user's age. Let's say I asked a user to provide their age. They say it's 15. Now I want my application to be used only by people who are above the age of 40. So I want to check something, which is whether the user's age is above the age of 40. Not 40, above the age of 40, which is 41 and anything above 41. So to do this, all I have to do is type in x is greater than 40. Since current age is 15, it's not equal to 40, I get false. This is a value that I can use later on. I'll show you how I will do that in conditionals, but right now you need to understand that this is what's telling us whether or not a particular statement is true or false. User's age is greater than 40, the compiler is telling us no, it's not. The user's age is 15 and it is less than 40. So we get the output as such. So different kinds of comparisons are available, such as less than, which is this, greater than, which is this, equal to. So if I want to check if user's age is equal to 15, I can just use this. In JavaScript, there's triple equals also available. Since JavaScript is a dynamically typed language, if you want to compare 15 to be equal to 15, you will get true here. Because what JavaScript will try to do is it will either convert string to number or this number to string, and it will check whether or not those two values are the same. But if I use triple equal, that means strict equality. That basically says, okay, whatever the value is, it needs to be of the same data type and the same value as well. Don't juggle the types for me. Just tell me if it's the same. And here it's false. So that's another operator. So we have taken a look at less than, greater than, and equality operators. What about not equals? So I want anyone to be able to enter this application who is not the age of 44. For some reason, I don't want anyone to be of the age of 44 to enter this application. Right now, age is 15. It is not equal to 44. This exclamation point simply means that it's not. So that works. Now, the other operator that is available for us, apart from a equality and not equality, is something called greater than and equal to. So let's say I have the age to be 20. And I want to check if anyone who enters the application is of the age 20 or above. This is true. If I remove this equality symbol, that means that age is not greater than 20, it is equal to 20, so it's not going to be true. This checks both whether or not a person's age is greater than 20 and equal to 20. Similarly, if you want to take a look at less than and equal to 20, this will also work. It's equal to 20, but if it's not less than. And again, if you want to take a look at whether they are equal, that's true as well. So these are the comparison operators that we have available. Now we have logical operators as well. Now logical operators allow us to bunch together the different comparison operators. Let's say that I have the age of a person to be 18 and their monthly income, let's just variable age is 18 and income is equals to 15,000. Let's say I'm trying to create an application where person whose age is 18 and income is 15,000 are allowed to enter. So anything above that can be used. So how can I check two conditions? Basically, is the age equal to 18? That is true. Is the age equal to 15,000? Oh, sorry, not the age, it's the income. That's also true. But how do you check these two things right at the same time? So this is where the AND operator comes. So age is equal to 18 and income is equal to 15. So this works. This basically means this statement is only true when both the conditions are true. So this is equal to 18 and this is equal to 15,000 as well. If both of them are true, then it's true. And you can also add other things as well, such as if the age is less than 19, which is going to be true because 18 is less than 19, so it's going to be true. But this is just to show you, and you can add more conditions like this as well. Now, what if you want to check only one of these conditions is true? So either the income is equal to, let's say, the age should be 20, but if the age is not 20, but the income is equal to 15,000, then they can enter. This is where you use the OR operator, which is these two pipe symbols, and that's where you can do that. Doesn't necessarily mean that that's the only way. You can mix and match these operators. You want to check two things and multiple things as well, you can do that here as well. But these are the basic comparison of basic logical operators that you can use. The last logical operator would be not. So if I want to check, okay, is age equal to 50, but I want to check if the age is not equal to 50. So I can just and age is not greater than 40. So if I want to just make sure that whatever the answer of this is going to be, I want to just invert it. If it's true, make it false. If it's false, then make it true. Then use the not operator, which is the exclamation point, and this will work. This will flip the result on its head. So these are the three operators that are available for us there. Now we have the bitwise operator, which you can use. Bitwise operators are only useful when you're working with binary data. So let me just show you the binary data that you have in order to check whether or not the binary data is going to be worthful for you. Binary data is useful because underneath the hood, it will always take a look at the binary representation of the data. We write the code, but it doesn't necessarily mean that the code that we are writing is going to be written in binary. So one way to think about it is this. Let's say that I have a number 5, right? Now that number, if I want to take a look at the binary representation of it, I can just write toString. It will convert it. This is the toString, and so this is basically something that will work if I just type it. Variable x is equals to 5, x dot toString 2, and this is the binary representation. The reason why we have to write 2 here is binary is something that needs 2 as its base. So the normal decimal number system that we use, which has numbers from 0 to 9 being used throughout, in binary you only have 1 and 0. So underneath the hood, the computer can only understand ones and zeros. So that's why binary numbers are so important in computer. Now let's say we have this, and we can perform different kinds of operations here. So x is 101 and 2 dot toString 2, y is equals to 2, and if you have y, you can take a look at 10. So we have 101 and we have 010. This 0 is just padded at the end so that these three variables come in line. So now if I want to perform some binary operation such as AND, or not, in case you're not familiar with this, don't worry about them. But if you are, you're working with some low level techniques, then you can just use x and y. And then what you can do is you can just z equals to x and y. So it returns the value of 0. We check the binary representation of this as well, and we get 0. The reason why is because if you remember, we have 101 and 10. What happens is it takes a look at the 101 and 010 numbers, and it takes a look at the adjacent pairs. So these are the two numbers that are right next to each other. So if they are both 1, then only the output will have 1 in that place. So 0 and 1 will return 0. 1 and 0 and 0 and 1 is also going to return 0. But in case I had done this, now I have 7. And if I want to check why, I can just press Z. If either of the number is 1, then we're going to get 1. And 111 in binary will convert to 7 in decimal. And there are many other operators available as well, such as 11, 2, shifting the numbers by 2 and something like that. So 11 by 1 is 22. And if I were to shift 11 to the left side by 1, it's also this. So that's the way binary operators work. There are many other binary operators available for you to use as well, but that's one of the ways you can do it. So these are all the operators available for us to use. In many programming languages, multiple operators are available for you to use. If you have already worked with any programming language, these operators may seem familiar. The binary operators are operators that you would not have to use unless you are working with some binary data and you want to manipulate it underneath the hood, which is quite rare. Other than that, you can use any of the operators that we have discussed. All right, let's see what else we can take a look at. All right, guys, now let's take a look at conditional statements. So conditionals or conditional statements are used to make decisions in a program. As we have taken a look into operators and we determined how we can use conditional or logical operators in order to figure out if something is true or false. Based on these values, we can then define how we want our code to perform. So for instance, if we have some code, and in that code, what happens is you want to get the user's input and then determine whether or not a person's input, the input that the person gave, which is the person's age, is less than 18. If it is less than 18, then they cannot access your website. Let's say that it's a voting portal and above the age of 18 is the person that can vote in your country. So that's the threshold that you have determined. So that's the way it's supposed to happen. Now you can check using the operators that we have discussed, but how do you determine what code to run when a particular condition evaluates to true? This is where conditionals come into play. Now in conditionals, we have multiple ways of dealing with things. We have if, we have else, we have switch statements, we have if else, nested else if statements, and there are many other kinds of operators that are many other kinds of conditional statements, which we'll take a look at. Also, we'll take a look at ternary statements. Now, ternary operator is an operator that we didn't really take a look into when we are discussing operators, but we did allude to it mainly because the ternary operator is a substitution for a simple if statement. So if you have an if statement that's really simple and don't want to write that much lines of code, you just want to write a single line of code that will explain it all. Ternary operators are really useful in that. It's called ternary operator because we have already discussed unary and binary operators. In a ternary operator, we have 3 operands. So in unary operator, we had one operand, which was the increment and decrement operator and the variable that whose value we were incrementing or decrementing. Then we had binary operators such as addition, multiplication, and division operators, and other operators as well, such as assignments and all. And now we have ternary operators. So these are the things that we'll discuss in the hands-on. So let's take a look at that next. Now let's take a look at loops. Loops are used to run multiple times until a specific condition is met. So let's say that you have some code that you want to run multiple times until a specific condition gets met. Let's say that you want to print the multiplication table of a number that the user enters. Now for that, you could write 10 console.log statements, in each of which what you will do is you will increment the number from which you're multiplying that number from. So let's say the user enters 3. So you write 3 multiplied by 1 is equals to 3. 3 multiplied by 2 is equals to 6, and then you keep going on like that. That would be useful. However, since there's a lot of repetition of code and only the variable, only the counter is changing from 1 to 10, we want to automate this process. This is where loops come into play. Now, this is not the only place where you use it. In fact, loops are so fundamental and core to programming that they are used multiple times. So basically what we're doing here is we're saying, okay, we want to execute some bit of code. However, we want it to be executed for n number of times. This comes in handy when you have container objects such as arrays and objects, which we'll discuss after loops. But this is also helpful when you're trying to just go through something for a n number of times. In cases like this, loops are really helpful. Loops are of three types: for, while, and do while. We'll cover all of those in the hands-on, which we'll take a look at.
Okay guys, a quick info: if you're looking for an end-to-end training in JavaScript, Intellipaat provides a full stack web developer course which covers JavaScript and all the JavaScript frameworks you need to know. For more details, check out the description box.
Alright guys, so now let's take a look at a hands-on using loops. Again, the setup is going to be the same. We have some code. Let me just zoom out a little bit so that it's really easier for you to see. And I have the same code editor. Now let's write some code to make sure that we understand. Let's say that we are getting some number from the user. Let's say for num is equals to pass integer prompt and a number. Now I want to print the multiplication table of a number. Now multiple ways I can do that. One way would be to use this syntax, and now we can just do it again and again for 10 times. Let me just start from the beginning so that you can see. 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 9. So if I were to save this, it would work if I just named the work console correctly. Now that that's done, I'll save it, go back, refresh, 5, press enter, and 5 multiplied by 3 is equals to 15. It's just a little, now it's going to be visible intact. I think there's an extra space between multiplication and equals to, so let me just correct that, save this, go back, refresh this, 5, enter, and now the code is correct. So 5 multiplied by 1 is 5, multiplied by 2 is 15. Oh, that's not correct. Again, as you can see, the mistakes that we are making even when we're manually trying to recreate some code. It's 5, press enter, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so it's correct. Now the issue is that let's say that the person says, okay, I don't want it just to be there just till 10. I want it to be there till 20. So 5 multiplied by 11, 12, 13, 14, 15, 16, 17, 19, 20 till there. So now again we have to write the same code and we have to make the same changes. This is very tiresome. So in order to overcome this, if we take a look at the code, the only thing that is changing is this number, right? Here and here. So we can change that. And here where loops come into play. So for variable I is equal to 0, I will be the number that we will multiply it for. I is just a common variable name that we use for loops. I is equal to 0, I is less than, let's say, 10, but we want it to start from 1, less than equal to 10, and I plus plus. Now all I need is just one line of code. The rest all can be put aside. So number plus I, save this, go back, refresh, 5, enter. So 5 multiplied by 1, 2, 3, 4, and 8 works. So what just happened is, so this is the piece of code that's different. So let us explain this one by one. So it has 3 parts. The initialization phase, in which we initialize a variable with the initial value. Here we have initialized a variable named I with 1. The condition phase, where we check if the condition is true. If this condition ever evaluates to false, that means we have met the condition we wanted to meet and we want to quit the loop. And this is the change phase in which we increment. So the way it works is our JavaScript interpreter takes a look at the loop, creates a variable, assigns value 1, then checks if 1 is less than or equal to 10. This condition evaluates to true, so this code gets executed, and then we increment 1, so it becomes 2. So we check again, if 2 less than or equal to 10, it is, go back, put number plus, and we create the string where number multiplied by 2, which is the current value of I, is equals to number multiplied by 2. then we increment, it's 3, and the same way we keep going till we reach 10. We check if number is less than or equal to 10. 10 is equal to 10, not less than, so we execute the code. Incremented by 1, it's 11, and now this condition evaluates to false, so we just come out of the loop. Nothing left to execute, so we just end our code. So that's the way for loops work. For loops are the oldest loops. They are used in many programming languages. Any programming language that you wish to use, you can use. Now, if I were to show you the same problem that we had earlier, let's say that the person says, I want the program to show me the multiplication table till 20. Run this, and it's showing till 20. You can even go further to 30, 40, 50, whatever you want, but now it's just a number changer. So as you can see, it allows us to not repeat ourselves, allows us to not errors, and allows us to write code that doesn't contain any error because most of it is automated by the computer. So that's just one kind of loop. There are many kinds of loop available, and we'll take a look at them one by one. Now, instead of getting the input from the user because it's a little tiresome and a little difficult, I'll just assign it right now. Fine. So this is one kind of loop. Let me just comment it out so that it stays here, but it doesn't get executed. So this is none. Now I'll show you while loop. So this is what it looks like, but here some things are going to be different. So the initialization phase, I is equals to 0, I is less than equal to 10. Then we are going to use the same thing that we had written earlier, and I plus plus. So as you can see, we have the same 3 bits, but their position has changed. Earlier, we had them all written in the same place. Here we have I, which is the index variable, and it is at the top. We can declare it anywhere we want. It doesn't necessarily have to be here. Similarly, if we had declared it earlier some places, we can just drop the var keyword and it will work just fine. Now, we have I equals to 0. Now we check if the number is less than equal to 10. As long as this condition is evaluating to true, we will continue printing whatever it is inside the code, and we will check again. So we check it, we print, we increment, check, print, increment, check, print, increment, check, and we keep doing it again and again. If I go back, refresh, I get the same thing. However, this time it's starting from 0, and that is because I had my variable set to 0 where it should have been set to 1. Although 0 works, but still it's the way it works. And now we have that. So this was a while loop, and this works as well. Again, let me comment it out so that you can see. And now let me just show you the do while loop. This is what it looks like. So we just need a condition here, and it's going to work exactly the same. Variable is equals to this. This is the code that we want to execute, and the while loop is going to be just if the I is less than or equal to 10. And finally, we have to increment it as well. Again, this is going to work exactly the same. If I go back, refresh, it works. But there's a bit of an issue here, or not an issue, but the difference between while loop and do while loop is not just semantics, because they look exactly the same. But what happens here is, let me just remove this. Yeah. So now it's going to print it, then going to print it again. What happens is, if I were to change this variable to be 11, and if I were to change this variable to be 11 as well, what happens is, if I go back and refresh, 5 multiplied by 11 is equals to 55. So what's going on here is, in the do while loop, we have the variable set to be 11. We print whatever we wanted to print, then we increment the value by 1, and then we check the condition. In the while loop, we check the condition and then we print something. So that's the whole difference. It's called the entry controlled versus exit controlled loops. In entry controlled loops, before the loop starts, we take a look at the condition. If it evaluates to false, nothing gets executed. In exit controlled loops, at least once the code gets executed. But if the condition evaluates to true after the execution of the code, then we get this. Even then, we will still print something. So for instance, if this code is printed, that means that this condition, even if it didn't evaluate to true, we will still print it once. Then it increments, so 11 becomes 12, and we check if 12 less than or equal to 10. It's not. It is not equal to or less than 10. It is greater than 10, so the loop exits. So that's loops in a nutshell. That's how loops work in JavaScript and in many other languages. These are the 3 kinds of loops. There are other kinds of loops as well, which we'll discuss once we are done with arrays and objects, because those kinds of loops are used there. So we'll take a look at that in the array section. So let's take a look at the arrays now. Arrays. So an array is a container type. A container type is used to store variables or values of different types. So arrays are used to store multiple data points or multiple fragments of data in a single variable. To give you an example, let's say that you want to store the marks of a particular student and you want to store all the marks in one variable. If you were trying to store the marks of a person in English, Hindi, maths, science, geography, these 5 subjects, you can create variables with these names and you can store the data inside them. However, if you want to store them all inside a single variable, then you can use arrays. Arrays have two parts to them, indexes and values. Indexes are you can think of them as roll numbers. So they start from 0 and then there's the marks of the student. So whatever you insert at the beginning will go at the 0th index, then the first index, then the second index. In JavaScript, arrays are dynamically sized, so you don't have to worry about running out of space, or you don't have to worry about declaring an array of a fixed size because they size dynamically. So you can store as much information as you want. In other languages such as C++ and Java, you would have to declare an array of a specific size and then use that array only. You can't use multiple arrays. So that's the difference between the arrays in JavaScript and other languages. Also, in strongly typed languages such as C++, Java, you would have an array that can only store value of one type. So if you want to store integer values, you can only store integer values, only store string values or other kinds of values. On the other hand, here we can store values of multiple types in an array. So we can store a variable that is of type integer, then string, then boolean, then again integer, then again boolean, then again integer, and many different kinds of data in any format that we want, as long as it's supported by the language, they can be stored inside an array. In fact, we can store an array inside another array, and that also works. So that's how this works. Let's take a look at a hands-on and figure out how arrays can be used in JavaScript. So again, to follow along, just as we had done earlier, just need to have an index.html page, open up the console, and open up the code file. So here's what we have. We have used the useString. Now we'll take a look at multiple operations that we can perform on arrays. But first thing we have to understand is how you can create an array. To create an array, it's quite simple. I'll use the var keyword. I want a new array. So I want an array of the marks of a student. I'll call it marks, and I'll assign it to this. This is an empty bracket. I save it, go back, refresh. Now if I take a look at marks, it's an empty array. Also, there's an array constructor as well. So if I just use the new array function, this will return the same thing as well. But we don't need to get ahead of ourselves. This is how we can create an array. Now, creating an array is quite easy. You can just create an array, but how do you initialize it? So this is an empty array. If I want to add some values to it, let's say that the student has 88, 56, 55, 44, 55. These are the 4 marks. Go back, refresh marks, and these are the 4 marks. If I expand this here, we'll take a look at this. This is the index, which is corresponding to the variable. Since this was the variable I inserted at the beginning, or this is the data that I inserted at the beginning, it got the number 0 associated to it. Similarly, 1 was associated to 66, 2 was associated to 44, and 3 was associated to 55. And I have a property length, which tells us the length of the entire array. So basically, if I were to take a look at marks.length, it will show me the number of elements inside an array. That's one way. If I want to access certain values, let's say I want to access the value at the beginning, there you go. So I can just use this 0, 1, 2, 3 to get the values. So 1 would give me 66, 2 would give me 44, and 3 would give me 55. Now what about 4? Well, it will give me undefined, mainly because these indexes don't exist, so they are not available for us to use. So if I go back, this is what it looks like. Now, as we know that we use indexes, and indexes are sequential, so 0, 1, 2, 3. They are assigned on the basis of arrival of the data. Now, if I want to go over these and print all of those one by one, what I can do is I can use a loop for variable I is equal to 0, I is less than, and here's where the marks come into play. Marks.length and I++. So it will go from 0, 1, 2, 3. As soon as I becomes 4, it will exit out of the loop. So we'll only get 0, 1, 2, and 3, which are the valid indexes. And I want to print marks of I. Save this, go back, refresh, and here you get the numbers. Now this is where a simple for loop works, but another thing we can do is, instead of using this because it is a lot of values, what I can do is for variable x in marks, and if I print x, go back, refresh, here's where you get 0, 1, 2, and 3. So you get the indexes and you can do it there as well. And there's a for off loop available as well that you can take a look at. You refresh and here which you get values. So if you want to take a look at the indexes, you can just go for x in and it will get you that. If you were to go for off, this is how it would work.
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which of the following is not considered as an error in JavaScript? A. Syntax error. B. Missing of semicolons. C. Division of 0. D. Missing of brackets. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this is how these variables work. In other languages, you would have to do something like this, especially in Java, but here it doesn't work like that. So that's the way you can loop over an entire array. But how about you have an empty array and you want to enter some values into it? The easiest way here is if I go back to my code, I'll just show it to you here. Let's say ARR is equal to a new array. Now if I want to add new data into it, all I have to do is ARR, this is empty right now, dot push. Push is allowing me to insert some values. The F here means I have to put these brackets here. This means it's a function. Don't worry if you don't understand functions right now. I'll explain it to you in a moment. But let's say that I want to enter some item. If I want to enter just one number, I can just enter 15, press enter, and now ARR has 15 values. But if I want to enter more numbers, 16, 17, 18, all of these will be inserted as well. And there you go. It returns the length of the array. So whenever we insert something, it will get back the length. So since we inserted 3 values after 1, we get 4, and this is what's returned. So we have these 4 values. Now that is done. But let's say I want to remove the element. I can just pop and this will remove things at the end. Now instead of getting 15, 16, 17, 18, I get 15, 16, 17. If you pass in a number in pop, it will remove, it won't make much of a difference. It will still remove the same thing. Similarly, it won't throw an error basically, and you have one value. If I were to pop again and then again, since last value was removed, nothing is here, so you can't have anything. As we discussed, arrays can have values of multiple types. So let's say it's a string 0 true. ARR is equals to this. Now, if I want to find the value, I can find the last index of true. So true was found at the second index. This is easy for me to find things. If I want to find some string but it doesn't exist, it will return me an index of -1. So that's how it works in arrays. Arrays are really complicated in JavaScript. You can have a lot of functions. A few functions that I'd like to show you that are very important. Let's say that I have numbers. This is an array that has 1, 2, 3, 4, and 5. Now suppose I want to create a new array out of this array, and what I want is all of these numbers squared. So 1 multiplied by 1, 2 multiplied by 2, 3 multiplied by 3, 4 multiplied by 4, and 5 multiplied by 5. Simple logic that we have learned so far is use for loops. Go over each value for var x of, and inside it we pass in nums. Let me just show you in the code. So I'll just copy here, paste it here, then var result is equals to an empty array for var x of nums. We get x and result dot push x multiplied by x. Now if I console log the result, save it, go back, refresh, this is what we get. So we get 1, 4, 9, 16 and 25. This is exactly what we want. Now this works, but as you can see, again you have to write so much code to get something really simple done. In other way, if you want to do it, I can show it to you right now. Result is going to be equal to, and I take nums and I'm going to call a method on it called map. This function, it will take another function, and I'll display and show you what that means, but this is called functional programming. We'll discuss more about this when we are discussing functions, but right now just take a look at what happens. I'll just return x multiplied by x, and this is done. I save, go back, refresh, and I get the same output. So as you can see, multiple ways of doing the same thing in JavaScript. Some are more concise, however it takes a little bit of time to get around those. Some are really easy to use. So we have understood how to declare an array, how to add elements to an array, remove an element from an array, access elements from an array, and loop over the array. These are the basic functionalities. If you want to take a look at the functions available for arrays, just type in nums dot, and you can take a look at all the different kinds of values that are available for you to use. Shift, unshift, slice, reverse, reduce, and many other kinds of functions such as index of and last index of. The difference between the two is that index of will give you the first index that it finds of a number. So let me just display that for a moment. Let's say that array is equal to 1, 1, 2, 2. I want to find the index of 1, I get 0. But if I were to find the last index of, this will give me 1. So if you take a look at this, first time I encounter 1 is at the 0th index, and the last time I do it, it's at 1. If I were to change this variable here and add 1 at the end, now if I were to use index, the value is still the same. But if I were to use the last index of 1, I get 5. So this is the difference between the two. Let's take a look at objects. So objects are the fundamental type in JavaScript. Objects are really important in JavaScript because most of the things that we work with are essentially objects. Objects are container types. Basically, they contain other kinds of data. Objects can contain objects, arrays, and any kind of data that they want. Similar to arrays, they are also heterogeneous, meaning that they don't need to contain only one kind of data. They can contain different kinds of data. The only difference between arrays and objects is that in basic uses is that objects will use key value pairs. Now, key value pairs are really easy to understand. Basically, just like in arrays, we have numeric indexes that are automatically assigned as you add and remove elements. So as soon you create an empty array, there's no elements in it. You add new item to it, it gets the index 0 assigned to it. Then you add another item, index 1 is assigned. Then you add another item, index 2 is assigned. When that element is removed, index 1 is the highest value of indexes there. And then when you add another item, index 2 is assigned again. So as you can see, it's sequential, increases and decreases based on the length of the array. Now the difference here is that in objects, you can, instead of assigning 0, 1, and 2, it's up to you what you assign to the values. So basically, if you are trying to create a table-like structure in which the name of the person is supposed to be the key and the value is going to be their salary, you can do so. Just put their name as the key, salary as the value, and keep doing it for all of those, and it is an object. Objects are also fundamental in JavaScript because they are very synonymous to other kinds of objects, such as if you've ever worked with say object-oriented programming in other languages, and object-oriented programming is something that we'll discuss. But in object-oriented programming, you have classes and objects. Those are slightly different from what we're covering right now. So don't worry if you don't understand them right away. Basic idea behind this is that objects are containers that can contain key value pairs. They are more similar to hash tables or hash maps than they are, or dictionaries if you are in Python, but they are more similar to those than they are to classes and objects in the traditional sense of object-oriented programming. In case you don't know object-oriented programming and hashes and all of that, don't worry about it. We'll take a look at a hands-on in which we'll understand what this actually means. However, if you are familiar with these topics, then you have a nice ground level understanding of what this is. How to use it, however, is something that we'll cover on a hands-on. Alright guys, now let's take a look at a hands-on involving objects. So for this, firstly, you need a web browser opened. You can open it up in any web browser that you want, as long as it has a JavaScript console. To get into the console, just press Ctrl+Shift+I and then click on console. Expand this a little, and yeah, now it looks. So the way you can create an object is very similar to the way you could create an array. So for arrays, you needed to use either this shorthand, which were two brackets open and close, or you can create new array, right? And that would also create an object. Now to create an object, however, it's quite easy to do. All you have to do is either just create a new object, which is exactly the same, or if you take a look at the symbols below, you can do this as well, and you have an object here as well. So let me just show you. If you take a look at type of, it's an object. Also, if you take a look at the type of array, it's an object as well. As I said, object is the fundamental type. Every thing that's not a simple primitive type, such as boolean, string, and all of that, that's an object. So you take a look at that. This is a string, but this is an object. So arrays are also kind of an object. So now, if I want to create an object, I can just assign obj is equals to, and here we have it. So if I create obj now, it's an object. Again, if I wanted to do it the other way, all I had to do was create a new object, and this works as well. It's exactly the same thing, as you can see. Now the object is created. Now it comes time to add things to an object. Now, as I said, objects are key value pairs, right? So one way you could have done this is, if you want to create an object here, you can just add things right here. So let's say that I want to create an object in which the key, I'm trying to store the name and address of a person, or let's say name and salary of a person. So all I have to do is type in name, and the name is supposed to be whatever I want it to be. Let's say John. Then let's say salary, 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 and let's say the salary is going to be 50,000. As you can see, that name is string, salary is not string, it's number. So you can do it this way as well if you want to. It doesn't really matter what kind of value you have for the values. Also, if I wanted to remove these, I can do so as well. JavaScript will automatically convert them into strings, so I have this. It doesn't really matter if I want string or not. I can also have numbers mapping to numbers as well. So let's say 2, 4. This works as well. Now if I create an object, I can take a look at the object in the console. This is what it looks like. 2 will map to 4, name will map to John, and salary will map to 5,000. In a similar fashion of array, I can also access these things by indexing into it. So if I type 2, you have 4. That's not the only way you can access things though. If you want to access the name, I can first type object.to. This will give me an unexpected error because 2 is a number. But if I access it using the array syntax, it will work. However, if I were to access obj.name, this will give me John. If I were to access obj.salary, this will give me the salary of a person. So this is how you can get the information from the objects. So this is how you can create an object and add data to it right at the same time. But how about if you want to create an object on its own and then add data later on as the user adds it? So again, you can just create an object which is an empty object, and now if I want to add anything, the same thing I would do anywhere. I would just type in obj, and now I can do it in the same syntax that I had done earlier. So I can type in name to be equal to John. Now if I take a look at obj, this is what it looks like. Also, if I want, I can type in name dot salary, salary is equal to 50,000. And now if I take a look at obj, this is what it looks like. So this is how you can add data to an object. This is how you can create an object, how you can initialize an object, add data to an object. Now let's take a look at how you can remove data from an object. So if I take a look at this, it looks like this. If I were to take a look at name, and now if I delete it and then take a look at obj, it only has salary. So this is how you can delete it. Use the delete keyword in front of the object and the key name that you want to delete it, and it will delete everything. Now you have just one property or one key, salary, and one value. This is 50,000. These are the keys, these are the values. So this is how that works. Again, if you want to loop over an object, you can do so as well. Let me just again, yeah. So now we have obj and we have name and salary. Another thing to notice is that it doesn't really matter how you add things into the object. If I add name first and salary first, it doesn't really matter. It's really fast for lookup. Also, if I try to access an element that's not inside the object, let's say not found, it will return undefined. So just be sure to use this. So if I want to check whether or some key exists inside the object, the quickest way to do it is check if it's equal to undefined. So this is going to be equal to undefined. Name is not going to be equal to undefined because we have name equal to John. Now if I want to loop over the objects and print everything inside it, all I have to do is use a for loop for variable key in object console.log key plus, and this is string concatenation, and you press enter and everything is working exactly the way it should be. So the salary mapping to value, name mapping to this value, and this works easily. So this is how you can write code and have it be executed. Now again, another thing I'd like to show you, which I hope I have shown you by now. If I were to remove these curly braces, what do you think will happen? It will still print it. So the difference between the two is, let me just show you. So this is what it should look like without the curly braces, right? If I were to add another line right after this and say next property. So if I press enter, as you can see, first the loop executes this, and then next property. However, I want both of these statements to be executed in the loop. Now for that, I have to open up a curly brace and then close the curly brace. And now if I do this, this is what happens. So what's going on here is if I remove the curly braces, only the first statement gets executed in the loop's body. If I keep the curly braces, then everything inside the curly brace is included in the loop's body. So for instance, if I were to add new code lines to it, they will also get executed. So this is a good trick to remember. So if you have an if statement where you only have one thing to do, so let's say that 1 is equal to 1, then I want to print console.log true and press enter. So it will work. However, if you have multiple statements, then you don't use curly braces. Depends on the code style that you prefer as well. I would recommend that you use curly braces whenever you can, but however, if you take a look at code like this, don't think that it's invalid. It's perfectly valid. So now we have looped over the elements. We have taken a look at everything. Another thing that I can show you is the object function. So functions are not something that we have discussed thus far. We'll discuss them in a moment. But the object is in JavaScript an object itself. So you can take a look at a lot of things that these things have for us. These are the properties and these are the functions that we can use on objects to understand how to use them. You don't have to worry about them right now. This is just to show you that JavaScript has a really great inbuilt support for objects. If you ever want to use an object, you want to perform some task with an object, first take a look at the JavaScript documentation on Mozilla Developer Network to see if it's not already developed. If that feature or that function is not already there, then you can implement it on your own. Alright guys, now let's take a look at functions. So functions, as we have already discussed, a function is a named block of code which is used to wrap a few statements that should be executed one after the other and given a name. Think of bits of code that is really important to you. Any bits of code that come one after the other. So for instance, let's say that you want to connect to a database. That needs certain steps to be followed. You need to create the URL, you need to send a connection request, and then you need to handle whether or not the connection is successful or not. This is going to happen every time. These bits of code are going to be executed with each other. This is why we need a named block of code so that we can call it whenever we want to. This is a function. Another thing you can think about is how you can write data to a file. To write data to a file, you need to first open a file. After opening the file, you need to write the data into the file. Then you need to save the file. which is basically closing the file. So these three steps need to be executed one after the other all the time. So this is where functions come into play. You can create a function, call it write data to file, and that will do the same task for you again and again, so that you don't have to do it manually over and over again. This is what functions actually do. Now, when we come to actually understanding what functions are and how to use them, there are several intricacies that we need to be familiarizing ourselves with. Function names, declaration, calling a function, first class functions, which is a special concept in JavaScript, which will take a look at function arguments and returns. So we'll take a look at all of that as we move on to our hands-on. So let's do that now. So again, we would want to have the same setup that we did earlier. Create an index.html, open up the console, open the index.html inside a code editor. I'll be using Visual Studio Code. You can use any code editor you wish to use. And here I have used the use strict declaration so that JavaScript's interpreter doesn't allow for any small mistakes. This will keep our code clean and easier to use. Now, when we're talking about functions, let me just show you what a function is. Suppose I want you to create I want you to greet someone, right? So for instance, to greet someone, firstly, what you need is you need to console log hi, then you need to print hope you are well, and third one would be nice to meet you. Now suppose this is something that you need to use in multiple places in your code. So for instance, this is one thing. Now you want to, let's say your code is spread across multiple files, and now you want to use it in this file as well. This is a separate file. Let me just comment that out. File2.js. This is going to be the file name, and this is file1.js. So this is how it works. Now both of these files will be included and they will get executed. That will work. So if I go back, refresh, and this will be printed 2 times, which is good. Now what happens is someone comes along, takes a look at our code and says, this is fine, but after nice to meet you, put a full stop, just to make it grammatically correct. So after everything, put a full stop. I save this, I go back and I refresh. Now, as you can see that if the person did know that this code was also written by the same person in some other place, if they forget, basically if this code was written, this change was made 2 or 3 months after someone had written it and someone else is making the change, they have no way of knowing whether or not the changes are there. So what happens is this code and this code are now out of sync. Nobody knows that this code is also doing exactly the same thing, but this code was doing the same thing and had some changes applied to it, which this code didn't. So again, that's a bug in your system. So how do you come about doing this? Well, the way you do it is, again, the simple way in programming is that you do not repeat things. So let me just close this out, right? And now I can create a function for this. Function will allow me to give a name to this entire block of code, and that name is going to be referenced in other places. Any change I make to this function's definition is going to be changed in other places as well. To create a function, it's quite simple. Use the function keyword, function, function. Give the function a name. I'll call it greeting. Then use these. These are called parentheses. I'll show you what they are and why they're useful in a moment. And then we define the function body the same way that we had defined the bodies of loops and if statements. And this is where we are. Now, this is the function that we want to use. Let's say that this is in its own file right after use strict. And now if I want to call this, I'll just call greeting here, and I'll call greeting here. Whenever I want to call a function, that basically means, okay, this is a function, execute the code inside it. These parentheses are going to take a look at the function and execute everything inside it. So whenever you put a parenthesis after it, it basically means that this is a function and I want to execute it. I want to run everything that is inside the body of this function. So I save this, I go back, refresh, we get the same result. But now if I were to make a change that I had earlier done here, here, and here, save this, go back, refresh again. As you can see, the changes are reflected in both places. And this is a trivial example. It's in both places. In real world scenarios, this can be referenced in multiple places. So that's the difference we're trying to avoid. So that's one way. This is how you can create a function. This is called declaring a function or creating a function, declaration, and this is what's called using a function or calling a function. Call. Now that these two things are done, let's just return and see what else we can do. Suppose you want to perform some complicated mathematical operations, right? Let's say that you want to, I'll just call it calculate, right? A person enters a number to your program, and what you want to do is you want to take that number and square it, then add 2 to it, and then divide it by 2. So for instance, you take, let's say the number is 10, right? So you want to firstly square it, which is basically, you can either do it this way or multiply the number by itself. So number is equals to number multiplied by number. That's the first thing. Then you want to add 2 to it. So number is plus equals 2. And finally, number should be divided by 2. You can either do it number divided by 2, or the same way that we had done with the addition, you can do it this way. So that works. Now, thing is, this will only work with 10. So if I call this function, this will work with 10, calculate everything, but it won't do anything with it. Refresh, nothing happens. So what goes on at the end is that it creates a number in memory, performs these calculations, and then forgets about it because we're not printing it, we're not doing anything about it. So the way to deal with this is, firstly, we want to accept some input into our function. Now, either you can just call a prompt and say, okay, give me the user input. But this creates a problem that whenever you are using the prompt function, you're tying yourself to the browser because let me just look. Because prompt is only a function that is available in the browser. What if the user was to send the request via an HTTP request, and you are writing this code on a web browser? Instead of writing it here, you are writing it in a web server. That becomes a problem. So I just want access to a number. I don't care how I get it. So this is where parameters come into play. So I want a number, I put it here. So now whatever number user enters, I'm just going to square it, add 2 to it, divide it, and now I want to return the result. This is also quite easy. Returning a result basically means whatever I have calculated, give the result back to the user who called the function. Now I'll call number, save it. And now if I were to console log, and this will take a number. So if I enter 10, so go back, refresh, and this is the output. Let's check. 10 multiplied by 10 will be 100. 100 plus 2 is equals to 102, and 102 divided by 2 is equals to 51. So this is exactly what's happening. Now, it doesn't necessarily matter that I only need to have 2 parameters. I can have multiple parameters as well. So instead of number, I can also say value. And now, instead of 2, it could be 3, it could be 4, it could be anything, depending on your use cases. So I can here pass in 2, save this, go back, refresh, and it's the same thing. But if I want to make changes, I can just go 11 and 5. Save this, go back, refresh, and this is what you get. So as you can see that this works really well. Now, what is a function? It is basically a name given to a block of code. It can accept some parameters, perform some operation on it, and can return the output. These two things are optional. The function body, if it's not there, then it's basically just an empty thing. It's not doing anything. It's just a name for no code at all. So you can do that as well. Another thing that you might want to consider is that functions are first-class citizens in JavaScript. This is quite similar to other kinds of languages. However, most languages don't implement these kinds of things. So what that basically means is that instead of using functions as a high-level concept, it can basically be assigned to a variable. So let me give an example. Let's say I want to create first action is going to be, I can create a function without giving it a name. It accepts some value and returns that value multiplied by itself. That's it. And put a semicolon at it. Right? So this is the first action. Second action is going to be, it takes in a value and returns the value multiplied by 2. So now if I want to create a function, let's say I want function calculate. This will accept some actions and it will accept a value. So now what I want is for, and I can just go over each of the actions. So I just go for variable I is equals to 0, I is less than actions dot length I plus plus. Now all I need is to go to the actions, extract that function, pass in the value that was passed in, and I can just create a result. Result is going to be an array that will be passed in, and I'll show you what that means. Result dot push. Now I just have to return the result. So what's going to happen here is this. Now I'll call the calculate function, pass in the actions, which is going to be an array of first and second, and finally I pass in 2. If I go to console.log this, save this, go back, refresh. As you can see, this is what the output is.
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which event can be fired on a scrollable document element? A. Window. B. Scroll. C. Load. D. Unload. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
4 and 4. Now again, if I were to change the number, let's say it's 4. So I should get 16 and 8, and this is what I'm getting. This is the output. Now what's happening is, since I can assign functions to variables, I have created 2 operations on my own. Now what I want is the calculate function to accept a number of operations and a number itself, and perform these operations and return the result respectively. So it creates a result array, goes through all the actions, which is basically me trying to square and double it. I can also change the name here. SQ square and double. These are going to be the 2 operations I want to be performed on this number. So I send it to the calculate function. It extracts each of the functions, performs the actions, put the result into the action array, and returns it back.
Okay guys, a quick info: if you're looking for an end-to-end training in JavaScript, Intellipaat provides a full stack web developer course which covers JavaScript and all the JavaScript frameworks you need to know. For more details, check out the description box.
So that's what it means. Now there's another thing that you can take a look at, which is early returns, and this is really where the entire functional calls shine up. So let's say that I get an age. Earlier what we would have to do is, I wanted to check if age is greater than 18, greater than or equal to 18, then I would have to create another if statement inside it and do the same thing. Here I can do something else. So I can just check if age is less than 18, or income, which is something I need to accept as a parameter. Income is less than 50,000. Then I'll just use the word return. This basically means that, okay, if this is true, if either age is less than 18 or income is less than 50,000, then just return from the function. Don't perform any of the steps that I'm mentioning here. Other than, you can just write valid. That's it. So that's what you can do. Now your code is much simpler to read. It's easier to understand. Basically what it's doing is, if this is an invalid input, don't do anything, just return. Don't perform any function. So if I were to go console.log, oh, I don't have to console.log as well. I just have to use the calculate function. Pass in the age. Let's say it's 18 and income is 50,000. Save this. Go back, refresh, it prints valid. Now if either one of those turn out to be true, or and other one turns out to be false, it's not going to do anything. It's just going to move on. So this is how you can write code. So this is how functions work. We have taken a look at how to declare a function, how to call a function, how to compose functional callbacks, how you can do all of these things. One other thing that I'd like to show you that I didn't show you when arrays were being used is something called map, filter, and reduce. These are the three functions that are the most important ones in JavaScript when you're using arrays. Suppose you want to use an array. Let's say that I create an array of numbers, right? And I get numbers 1, 2, 3, 4, 5. Now I want to create a new array squared, which will be these numbers squared. So the way to do this would be, in normal terms, I would have to create an array, then I would have to write a for loop in which I'll perform these things. Here, what I can do is just type in the word numbers, and I used a function called map. Map is a function that takes in another function, just as the one we had created when we were creating squared and double functions. This function takes in a number, single number, not all the numbers. And now I want to perform my action and return the output. So I will return the number multiplied by itself. Now if I were to console log squared, this is what I will get. 1, 4, 9, 16, 25. So this is what we are getting. So what's happening is the numbers.map function is going to take this array, and what it's going to do is, in this function, it's going to pass each of these values one by one. So for instance, this, let's say this function is called, this is the function that is called. The first thing they will pass in 1, then it will pass in 2, 3, 4, and 5. And these values, when they are called, they will return. 1 will return 1, 2 will return 4, 3 will return 9, 4 will return 16, and 5 will return 25. So this is how mapping works. Basically, I want to create a new array out of a previous array. This is why functions are so important in JavaScript, and this is why they're called first-class citizens, because you can pass them around in other functions and nest them and do whatever you wish to do with them. This is why functions can be a little challenging when you're trying to work with them. So this was map. This is also part of functional programming. If I forget to return it, then I'm going to get this, which is undefined, because I forgot to return it. So what happens is, I take the number, make the calculation, but I don't return the result that I want to be included in the resulted array. So if I return it, only then would it work. Now you might be wondering, okay, this is a lot of code to write just to perform this task, right? And this is true, but when we move on to ES6 and its features, we'll understand how to overcome this as well. Now this is called mapping. If I wanted to filter it, let's say filtering would be something that we take a look at when we are trying to reduce the number of members. So for instance, if I want to only include even numbers, so I have 1, 2, 3, 4, 5, and I want to only return values. I want to only include values inside this array if the numbers are valid. So I want to check if the number mod 2 is equal to 0. Basically, if I divide this number by 2, if it doesn't leave any remainder, which is basically the definition of an even number, include that number in even. So 1 goes in, 1 mod 2 is 1, so it doesn't get included. 2 mod 2 is 0, this gets included. This doesn't, this does, and this doesn't. So now if I take a look at even, save it, go back, refresh, 2 and 4 are the numbers. So this is how filter works. So these are the kind of things that you would have to do and understand how to perform when you're trying to build a JavaScript application. We'll make heavy use of this when we're trying to build some other kind of application, but it's important to understand what it actually is. Finally, we can have a reduce function as well. Reduce function basically takes in initial and accumulated and return I plus accumulated and print, save it, go back, refresh, and you get 15. So what it does is that it passes in, let me just pass in 0 here as well. Now I refresh this. Yeah. So what it's trying to do is, it is taking this array, passing it these values. So it's passing in 0 and 1. So 0 plus 1 will equal 1. Next it will pass 1 and 2. 1 and 2 will equal 3. Next it will pass 3 plus 3 and 3. So 3 plus 3 will equal 6. Then it will pass in 6 plus 6 and 4, which will return 10, and finally it will pass in 10 and 5, which will return 15. Yeah, so this is what it's doing. Basically, we pass in the 0 as the initial value, and we're saying, okay, for each of the numbers, pass them here and create the next result out of those. So if we try to reduce the entire array into 1 by performing some function, this is how we do it. So that's basically it for the functions. Some of the important functions I have already mentioned. There are many functions available on many objects that you can take a look at. Too much for me to cover. I covered these functions that are map, filter, and reduce because these are the most important functions when it comes to writing JavaScript. They greatly simplify your code, and we'll learn in future videos how we can even specify better functional parameters to make it work even better. So let's take a look at what else we can learn. Alright, so now let's take a look at object-oriented programming in JavaScript. Object-oriented programming is a programming paradigm based on the cohesive units of code called objects and the descriptions that are called classes. So a class is basically a blueprint in which we describe the kind of data we want, the kind of functions we want, and what the class's name is what the entity is supposed to do. So to give you an example, if you're trying to build a painting application in which you want the user to be able to draw shapes, the kind of objects that you would have there would be circles, squares, rectangles. The kind of properties that they would have would be the length, width, radius, depending on the kind of shape you're having, and then the kind of functions that it will have would be draw, fill, and things like that. So these are the kinds of functions and data that we're trying to use. Now, why is object-oriented programming important? Object-oriented programming is basically a programming paradigm. It's a way to write code. Other paradigms include functional programming and procedural programming or imperative programming. This is exactly what we've been doing. Procedural or imperative programming basically means you write one code statement after the other and let that execute itself. On the other hand, in object-oriented programming, instead of code being just one statement after the other, we create small groups of code called objects. These objects are belonging to a specific entity and map onto that entity into the real world. So if you're trying to create a employee management system, one of the objects that you will create, one of the classes you will create is employee, then you can create managers and many kinds of things. Now, object-oriented programming is a really complicated topic. It can warrant an entire video on its own. Do mention in the comments if you would like for us to cover object-oriented programming in more detail, and we'll get onto it if you guys want that. On the other hand, here we have the object-oriented programming paradigm for us. JavaScript supports object-oriented programming, functional programming, and imperative programming all the same. But the way JavaScript supports, or the way that it has historically supported object-oriented programming, is a little different than the way the other languages have. So other languages have keywords such as class, which you can use to define the classes. You have constructors and many other kinds of things. In object-oriented programming, it's a little different. And in the hands-on, we'll see how it's different and how it works. So let's take a look at that now. So we'll try and create classes and objects. For this, I'll use the text editor. Again, the setup is the same. We just have removed some previous bits of code and brought it to its original state. Now, to use classes, you don't really use to, in JavaScript, you don't really create the word class there. We'll use the function keyword. That keyword will create a new class. Let's say I call it person. Okay, this person accepts two things: the name and age. Now I want this dot name to be equal to name, and I'll explain what this means in a moment. And this dot age equals to age. This is done. Now what I can do now is also, if I want to do something else, is I can just create a function. This dot say name is equals to a function which will console log the name. So you can do it this way, or another way of doing it would be to go here, use the person keyword, person.prototype.say name is going to be equal to a function, and you're going to print the name. Similarly, if you wanted to create an age, let me just do it here. This dot say age function, and type in console.log this dot age. Here it's the same. Instead of using name, I'll use this dot name. So what does the keyword this mean in this scenario? We'll take a look at that in a moment. Now I'll create a person, let's say John is equals to, and now create a new object using new person. It's the same thing that we have been doing thus far with the new array or new object constructor functions. And I'll pass in the name to be John and the age to be 35. Then I'll use John dot, and here I can use it to say its name or say its age. I can call say age function and then say name. Save this, go back to the code, create, open up the, and here you have it. So it prints the name, it prints the age. Now again, you can do it either way. Unfortunately, whatever way you prefer is the way that you should use it. I like doing it this way because it separates my my data with my functions or my methods. Method is basically a function that is tagged into a class. So what is going on? This is a constructor function. Constructor function. This is the prototype function or the method that we are assigning. So methods. So what happens is prototype is a property that the class takes a look at. So whenever we create an object, the first thing that happens is it takes a look at all the method names that we're calling. So we say, okay, I'm calling say age. The object will take a look at itself. Do I have a function named say age? No. Then it takes a look at its prototype. Does my prototype have a say age function? If it does, then I'll call that. If not, then I'll throw it. So that's how this works. So these are the two things. Again, it's a little difficult to wrap your head around at first, but it works. Now let's come back to the keyword this. This, what does this mean? Let me just create a new function, person.prototype.print this function, console log this, save this, and now I'll just call it here. Print this. And now if I go back, if I refresh, as you can see, this returns the object. So basically this is a keyword that is used to refer to the current object. Similarly, if I were to console log this here, which is outside the class, outside an object, outside a function, I will get window. So the way JavaScript works in the browser, it at the end everything is attached to window. Window is an object that is on the JavaScript browser. It is managed by the browser. You are supposed to add things or remove things. So if I create a variable here, var name is equals to Peter, and save this, and if I go back, refresh, if I type in Peter, okay, maybe I should type in name. So if I type in name, this is what I get. If I type in window.name, this is what I get. So this is what it means. Now, if you take a look at the keyword this, it is used to refer to the current object. So here, when I use the keyword this, it basically transforms this call into john.name. So to avoid confusion, it's called the this keyword or the context. Basically what we're doing here is we're saying, okay, for this object, the current object that I'm trying to create, whatever value I have assigned to the name and the age, print those. So this dot name means John's name, print that. This dot age means John's age, print that. And here this basically means print the entire John object. Don't print individual properties, just print it entirely. So this is what happens. If I go back again and I show you something, refresh, this is what it has. These are the two properties. Open it up. This is the prototype. Open this up, and it has these three functions: print this, print, say age, say name. And this is the constructor function that takes in the name and the age. So this is how JavaScript works underneath the hood. Now in ES6, there are new ways of creating a class, but this is how it works here. So you can create a class. These are the objects. Now you might be wondering, how is it different from creating a new object? Let's say I call it John, make it equal to this, put name equals to John, age equals to 35, and then I add these two functions. Let's say name function and the similar thing. Just think about it this way. So how is it different? Well, the main difference here is, let me just go back here. Instead of John, I'll just Johnny. Save this, go back, refresh, GOHNY, and this is here. Now, so the main difference is this is something that you can't reuse. Once you created the variable Johnny, that's it. Now, if I want to create another person with the same structure, here all I have to do with John, I will create Johnny, and his age is 40. So now it has all the properties that a person class has, which is this, which is the name and the age. It also has the name assigned to be Johnny, it has the age assigned to be 40, and it has these functions automatically. So I didn't have to create a new object, copy and paste the code. As we want to reduce the amount of code we write, we do it this way. So use these object literals, these ones that we create like this. You can use them, but use them when you want to create just one time thing. If you want to create something that needs to be accessed and change the data of multiple times, then these functions are important. This is how you can do it. Also, these data is also called, in case you ever come across this, it's also called properties, and this is how it works. So this is how you can create a class in JavaScript. This is the old school way. There are new ways of doing it, and we'll discuss this when we're discussing ES6. But right now, this is how you can create a class. It will work with all kinds of functions. JavaScript had a difficult start with object-oriented programming. It was earlier not designed to be an object-oriented language. Then object-oriented programming came into being, and now it's like this. So this is how you can do it. This is why functions were repurposed to be classes and objects. So you can do it this way. There are other ways which we'll discuss in later sections, but right now you can understand how you can do this. Right? Let's take a look at what next we can do. Finally, take a look at JSON. JSON stands for JavaScript Object Notation. It is a popular data transfer format which uses syntax similar to JavaScript object, which can be serialized and from and deserialized too. So basically what happens is, when you're trying to exchange information between two programs, and these two programs may be of different language, you need to agree upon some common format in which you will be exchanging data, so that when you create that format, put the data in and send it to the user can then take data out of that format and understand what you have written inside it. This is where JSON comes into play. Similar to JSON, there are other alternatives available, such as XML and YAML, or YAML as it's called. However, XML is quite old, it's quite verbose. YAML is quite new, but it's not very useful. JSON has turned out to be one of the most popular data exchange formats. It is based strictly on JavaScript object notation, which is basically how you create objects in JavaScript, with a few notable exceptions, although it's quite similar. We don't add functions and all, but we'll discuss those in the hands-on. Basically, JSON allows us to add data to an object, convert that object into a string, send it back to the user, which may be a Python program, which could be an Android application, could be anything. Usually it happens in client-server communication, but other programs do that as well. Once that data is sent, that data will then be passed and converted into an object that programming language can understand. And once that's done, you can then extract data from that object and use it however you wish to. Basically, JSON allows us to create a stringified version of our objects and parse a string in order to understand how to extract objects out of it. So let's take a look at how that works in the hands-on. So if you open up your browser, open up the console, and now let's take a look at how JSON works. Now again, JSON is like everything else in JavaScript, is a object in JavaScript. So let me just show you. And it contains a lot of functions that we can use for our purposes. In our case, it's parse and stringify. These are important functions, but first let's take a look at the syntax. So whenever you're trying to create an object, let's say that I am trying to make an object, I'll just create variable data equals to, and I'm sending back the information about the user. Let's say the ID of a user is 1, name is John, age is 56. So if I take a look at the data now, it looks like this. Now this is fine, JavaScript can understand this and it can parse it. But if I were to transfer this data to some other language or some other program such as Python, C++, Java over the internet, this will not work. Firstly, it will just be sending over a bunch of bytes that JavaScript can understand but other languages can't. So we have to convert this into a string. Now, to convert this into a string, we can't just wrap it inside this. For instance, we can't just do it this way because that makes no sense. Because let's say that if I have some double quotes in there and this is a long file, then this I have to go through the entire system. So the other way of doing it would be to use JSON dot stringify. Inside it, I'll just pass in the data, and as you can see that this has done it for us. It has double quoted the entire property, double quoted these things that we need, the properties that are string, and it takes care of all of that. So this is what the data is. Now if I want to send it to a user, I can send it. If I'm creating a web server, I can just pass it to the user. They will get this data. Let's say that I am that user, I get the data now. So I'll just get const string is equals to, not const, but variable string is equals to this. So now if I take a look at the stringified data, this is what it looks like. But if I want to parse it, I can just go json.parse the string and we get back the object out of it exactly the way we want. So this is what JSON allows us to do. Now suppose I'm creating a web server, I get the data from a database and I want to send it to the user. So sending it over the internet, I need to convert it into a string, which I do using this. So json.stringify.data, this is what gets sent to the user. Now let's say I'm creating a front-end application, I get the data and I want to convert it into the JavaScript objects that I can use. Just use json.parse on the data that you receive and it will work exactly the way you wish for it to work. So now this is how this works. There are other ways of dealing with data with JSON as well, but they are quite complicated and not very useful because they are really difficult to implement. Basically, you will be re-implementing the stringify and parsing functions yourself. That's not very useful, so we recommend that you do it this way. So with that, now let's take a look at what else we can do. Alright guys, now let's take a look at ES6 features. So JavaScript has been around for a while and new features have been added to JavaScript in its 2015 version. That was a major revamp of the language and it was called ES6. ES stands for ECMAScript. ECMA or ECMA is a standardization committee which takes care of standardizing JavaScript features across the browsers. So in 2015, JavaScript had a major revision called the ECMAScript 6 or ES6. It added new features and new syntax to make our code more concise. So this is basically syntactic tuning. New features were added in order to make our code easier to read, easier to understand, and easier to write. So these are some of the features, some of the most important features we need. So we'll be discussing those now. So let's take a look at them one by one. First thing is declaration. Now for declaration, what we need to do is we need to find out new ways of declaring a variable. We have already understood that there is a way of declaring a variable using the var keyword, var. However, two new keywords were introduced called let and const. And these were variables that were introduced because var had specific drawbacks, which we'll discuss. And then we'll take a look at how to use let and const instead of var. So to understand this, first we have to understand what exactly are the drawbacks. Then we'll move on to how these drawbacks are solved using this keyword. So let and const will take care of the problems that were created using var. Now let's take a look at the hands-on for declarations. So for this, we'll have to use the let and const keywords. So again, we'll go back to the same code. Now this var keyword is what we use to declare a variable, right? So if I create a variable named name, put John inside it, save it. Everything works and it doesn't really take away from the fact that it's going to work just fine. So if I take name, print it, it's the same thing. However, notice what happens here. So if I create if name is equal to John, then create a, let's say that we create a variable, it's called count, which is equal to 1, and then we print it. Console.log, there are count or there is would be appropriate. So now if I go back, refresh, there is one John. I think I printed 0 here somewhere. Count is 1 and the name is there is now, so there is one John. But if I take a look at the count variable, it's also available outside. So this is a problem. This is one of the problems. So what happens here is this: whenever we declare a new variable here, even if it's inside an if statement, it will be available throughout our code. So it will be available here. I can use it in another if statement as well. If true, console log count, and this will work. This is a real problem. It might not seem as such right now, but the problem here is this. Suppose you're working on multiple files and you try to create a new variable. This variable is now called, you create a new variable, you want to get the username. So you get the name, you ask for a user to enter the name, and what you have essentially done now is you have overwritten the value that might be used someplace else. So now if in some other file someone has already declared a variable name and they will use it when user clicks on a button or something, they'll get the name that you have declared instead of getting the name that they have declared. This causes a lot of issues when you're trying to build applications at scale, when there are multiple files that you need to take care of and how to work with them. So in cases like this, what we can do is we use the let keyword. The let keyword won't let the respects the scope of the variable. So if I go back, finally all I have to do is change var to let, save it, go back, and now if I try to use the word count, it says no variable named count is defined. This process of getting the variable from here, which is what happened with var, and putting it at the global scope, this is what's called hoisting.
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which of the following is not considered as an error in JavaScript? A. Syntax error. B. Missing of semicolons. C. Division of 0. D. Missing of brackets. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
This is a problem in older versions of JavaScript, and this is why the let keyword was created. Now there's another kind of variable called const. This is what const looks like. And contrary to popular belief, const doesn't mean that you will have a new variable that can't be changed. So for instance, let me show you. Const person is equals to, and let's say I call it a person. Now if I were to change this, I can obviously do so. Person is equals to another, and now I can't change it here. So that's the way const will work. It will not allow you to change a variable. However, if I had, let me declare another one. John is equals to, and John's name will be John. Now if I were to change John.name is equals to Jane, this is allowed because I'm not changing the reference of the variable, I'm just changing data inside it. So if I were to apply this, then it's going to get, because you can't reassign a variable that is declared using const. Had it been declared using let, so let's say let x is equals to x, and now if I want to assign y to it, I can. So this is how const and let work. This is the difference. The problem was variable hoisting. Variable hoisting basically means you get a variable and you assign it in some scope, and you don't want it to be accessible outside it, but it is accessible outside the scope, and that causes a lot of problems. So for instance, if I were to declare a variable here, this will be pulled out here, and then we'll be using it. When the JavaScript runs the code, it takes a look at all the variables, pulls every variable at the top, and now everyone can use this variable. So this would mean that a lot of people will be stepping on each other's toes, and it's going to be really difficult for them to understand what exactly is going wrong, where is this variable declared, and how can I get it to work better. On the other hand, once you're using this, you can use the let keyword, and this will respect the block scoping that we use. And the const keyword is used to declare constant variables. Now, which one should you use when? Basically, the recommendation that many JavaScript developers give is always use let and const. Now go start with using const at the beginning unless you need to change the variable someplace else. First use the const keyword, assign some value to it. If you need to change it someplace else, then change the const to let. Basically, don't use var, never use var because better options are available and this could lead to difficult problems. So that's how const and var work. This is what the new ways of declaring a variable is, and you should use them. Most browsers support these new ES6 features since they have been outside for ES 2015. So they have been available for public use since 2015, and most browsers support them. In case you want to convert this code into a code that older browsers can understand as well, there's something called a transpiler. So things like Babel.js, they will take your code written in ES 2015 and convert it into something that older browsers can understand as well. You can take a look at that if you wish to. All right, now let's take a look at what else we can do. Arrow functions. So arrow functions provide a new syntax to create anonymous functions in a very concise way. Since we have already taken a look at functions such as map, filter, and reduce, which take in functions as argument and give back in response the result of those functions, these functions that we pass in are called anonymous functions. They have no names, they are only used once. But it's a little difficult to write the function syntax the same way that we have done earlier. So in order to reduce this, since all we are doing is creating a function that returns some value based on the values passed into it, we can use arrow functions. Arrow functions are available in other languages in the format of a lambda. So if you've ever worked with Python, you can understand that arrow functions are similar to lambdas. Lambdas are also functional expressions that can be passed from one function to another. Similarly, this is what happens here as well. So now with that, let's take a look at a hands-on and understand how that works. So to take a look at arrow functions, I'll just open up this text editor and I'll show you what arrow functions are and how they work. So there's a bit of a variation on arrow functions as well, multiple ways of doing things with it. Let's take a look at them one by one. Suppose I was creating an arrow function, and from now on, instead of using var, I'll be using const. Unless I want to specifically know that this variable that contains data that needs to be changing, I'll use the const keyword, which is the recommended way. Now I'll create a function called f1. This function takes in a variable and it will return x multiplied by x. Very simple, everything that we have been doing thus far. So if I go back, refresh, F1, 2, enter, I get the result back. Now that works. However, this is a lot of code. Most of it is just unnecessary. We just want a function that takes in some value and returns some value out of it. So the way of doing it would be using x as the argument, equals to, and then putting the arrow symbol. This is why it's called an arrow function. And what we want to return is x multiplied by x. This is how this works. Now, if I were to go and call f1 again, it would work exactly the same way. And this is what's doing. Now, here's the thing that you need to understand. First things first, this is the list of parameters. If there's only one argument that you want to pass in, you can also skip the parentheses. It will work exactly the same. Go back, refresh, and use it, and it works. So what's happening is we're saying, okay, there's a function that needs to be assigned to the f1 variable. It takes in one argument, returns that argument multiplied by itself. And since there's only one statement that needs to be executed, I don't need to pass in any return statement and I don't need to write anything like that. So that works. However, if there was more than that, then I would have to make some adjustments. For instance, if there were two parameters, let's say x and y, then firstly I would have to wrap them inside parentheses. If there was only one, then I could leave off the parentheses and it would work, but right now I can't. Now again, I can just multiply and return x and y, and this would work the same. If I go back, refresh, go up, and do this, it works. But here's the thing. If I want to not just use one single line of code, but multiple lines of code, then I can write it here. So I can just write const z is equals to x multiplied by y. And then I will return z. This works. This works. So if I refresh, go back, run, and this works. So this is the basic function of arrow functions. You create a function, it's anonymous, you don't need to write a lot of code. Now compare and contrast this to a function that we had to create. So previous version was we would have to create a function that takes in x and y as parameters, and then we have to write the curly braces. We have to return the statement x multiplied by y. A lot of code to write just to perform something simple, right? Here we don't have to do that. All we have to do is just pass in x and y and return what we want to return. If there are more than one statements, then we need to wrap them inside curly braces and make sure that we return something if we wish to. If not, then we can just remove the return statement and it will return anything that this evaluates to. On the other hand, if we only have one parameter, then we can just leave off the parentheses as well. Although it is recommended that you use the parentheses if and when you can, because it makes your code more readable. So now where does this help us? Now again, suppose instead of doing it here, I'll do it here. Suppose I have numbers. It's equals to, and I take 1, 2, 3, 4, 5. Right? So if I take a look at numbers, this is what it looks like. Now, if I were to use the map function again, this takes in a function. Instead of passing in the function the old way where I use the function keyword, then take in the parameter, then write it here, and then I have to return something, which is this way, x multiplied by x, press enter. This is how it used to be done. Now I can simply write a really concise version of it, if you remember. As you can see, this is just 1, 2, 3, 4, 5 keywords that I had to type. Here I have to write this entire line of code. So it's very simple and very easy to use. And since I'm only going to be passing expressions, I can leave off the curly braces and parentheses as well. Let's say I want to filter. So I'll just use filter x and x mod 2 equals to 0. And this returns the even number. If I want the odd numbers, I can just do it this way and I get the odd numbers. Similarly, I can use the same thing for reduce as well. So if I take numbers dot reduce, this takes in the callback function in which I will pass in the initial value and the accumulated value and return initial plus accumulated, and the initial value right at the beginning would be 0, and I get it. So all I had to do was write just a little bit of code to get everything to work as I had expected it to work. So that's how these inline functions or anonymous functions or lambdas, whatever you call them, work. In the newer versions of JavaScript, they have proved to be really helpful. Many new languages have implemented these features itself, such as Java has implemented the functional capabilities in themselves as well. Also, these are really helpful when you're learning new frameworks such as Angular, React, Vue. They make extensive use of these functions because they make the code more readable. With that, let's take a look at what else we have to cover. Let's take a look at destructuring. So arrow functions are quite easy to understand, but destructuring is a little different from arrow functions. Instead of using the same syntax but modifying it a little bit, we'll be using a new construct in destructuring. So when we're destructuring, we can extract values from containers like arrays and objects in a very concise way. It often happens that we have an array or we have an object and we want to extract some values out of it and assign them to a variable. Now, when we're trying to do that, we want to, in previous versions, we had to index into the arrays or name the use the name of the properties there. But here we can use it ourselves. So in cases like this, we use destructuring. It makes our code really easy to use and really precise to work with. So let's take a look at that in a hands-on. Let's first take a look at the old way of doing things. So we had to create a variable. I will call it, let's say, names. This is going to be an array. And let's say that the array contained 3 values: Jane, John, and Jenny. So this is how you can use it here. But now if let's say I wanted to create 3 variables x and y and z, and I wanted to assign these values to them. To do that, I would have to use names of 0, similarly names of 1, and names 2. And now if I wanted to print the values of x and y, it would be x, y, and z. Save this, go back to the code, open up the console, refresh the page, you get Jane, Johnny, and Jenny. Now this works, and similarly for objects also. Let me just show you how that would work. Instead of names, let's say we had people, and we had an object here in which names corresponded to their age. John was 40 and Jenny was 37. Now again, if I wanted to get the age here instead of the names, I would have to again do something similar. Instead of doing A, B, and C. And now let's say that I want to extract the name of Jane. Then I would have to use the people.jane. And similarly, I had to do the same thing here, which is for John, people.john. And finally, for Jenny, I had to extract it like this. And now if I wanted to print, I had to print Jane, John, save this, go back, and refresh. And now we have this. I think I have misspelled something, that's why I'm getting for John, the J needs to be capitalized. That is the issue. Save this and this works. Now, if I wanted to, could just do it this way, Jenny. And now here, instead of having those capitalized names, I can just type the smaller letters, and this works as well. As you can see that this is a little tiresome to write. So how can we do it in a better way? Well, let's start with this. Let's keep these two things and we'll print these two things. But if I want to extract and destructure values out of it for x, y, and z, all I would have to do is this. So I use the array syntax and assign it to the arrays. Now if I were to print it, it should print the exact same thing. So if I refresh this, and it prints the exact same thing. So the way we did it is we created the array syntax and we added x, y, and z. These are the new variables in which I want the values to be assigned. Should be the 0th index should be assigned to x, first index to y, and second index to z. So that's how we do that. Now the same thing we can do here as well. So here, Jane, John, Jenny, all assigned like this. And now if I were to save this, if I were to go back, and if I were to refresh, the output is still the same. So here the name matters. Earlier I could have named it X, Y, Z. I could have named them A, B, C in the array restructuring thing. But here I have to name them correctly.
Okay guys, a quick info: if you're looking for an end-to-end training in JavaScript, Intellipaat provides a full stack web developer course which covers JavaScript and all the JavaScript frameworks you need to know. For more details, check out the description box.
So instead of Jane, I could have just written, if I were to write Jane like this, save this, go back, refresh, and I get Jane is not defined. This, if I were to go here and paste it here, go back, refresh, then I get undefined. This is because the keys are not matching up. So the keys that we have are Jane, John, and Jenny. If I want to create a variable of the same name, then I can just destructure it like this. And that's the way it works. Now, it's not the only way it can work. For instance, if let's say that I have a function, right? And I say, okay, print details. It will expect an object that contains the details of a person. And I want to print the name and age. And I call print details. And I can create an object first. Let's say Jane, in which name is Jane, age is 40, and if I pass the variable here, now if I wanted to print this, I would have to prefix the person, and only then will it work. If I save this, go back, refresh, it works like this. However, as we've already learned that we can destructure these things, so we'll do that here. So just paste it here and add it inside. So whatever happens is we pass in an object with name and age as keys. This will extract it and create variables out of it, and we can use them here. Now if I go back and refresh, it works exactly the same. So that's the way destructuring in objects works. This is why destructuring is considered so important, and this is why it helps us in writing cleaner and more concise code. Now let's take a look at the classes in ES6. Now let's take a look at the class keyword. So in ES6, we get a new way of defining classes. As we have discussed earlier, in JavaScript, creating classes and objects is a little tricky because unlike other languages, such as Java and Python, they have their own way of creating a class. And if you learn how to create a class and create an object in one language, you can pretty much learn how to do that in other languages as well. The syntax is going to be a little different, but the overall system remains the same, that you declare a class using a class keyword, create a constructor function, add variables to it, add methods to the class, and then you use the new keyword, or perhaps you don't use it in the case of Python, and you instantiate a new object of that class in which you can set the values and create the methods that act on those values and so on. So this is how you would do in other languages. In JavaScript, however, before ES6, what we had to do was, as we have already seen in object-oriented programming section, we have to create a function called the constructor function. That function's name is the name of your class. That function takes in a few values that you can set as properties to your class. And in the prototype of the function, you attach some functions or methods that are part of that class. After that, you can create a new object of that class and can use those functions. Now that works quite easily. However, this is a really weird way of doing it because you have to, instead of doing it the way you would normally do, which is basically just creating a class, creating an object, and functions and class are two different things in other languages. However, in JavaScript, they're all mismatched together, so it's a little difficult to get started with. However, in ES6, they have changed this. Now we can use the class keyword to create a function. Instead of using a function, you can create a class on its own. Now, what's happening behind the scenes is exactly the same thing that has happened with the function keyword, with adding methods to the prototype and all. But just because the new class keyword was introduced, we have a new way of creating class, which is much more easier than the previous way, and maps on to what other languages allow us to do. So let's take a look at that in the hands-on. For this, I have the same thing here. Now I'll create the same class that I had done earlier, which is the person class. Earlier I had to create function person and had to add some properties using name, age, then this dot name equals to name, and similarly this dot age would also become age. And then I had to add things to the prototype. Now this is doable. However, if I wanted to do this in class, it would be really easy. Just create a class, call it person. Inside it, I would create the constructor function. It is named constructor. It is called, and it allows us to create an object. Constructor functions are called constructor functions because they take in some parameters and create an object and give it back to you. So I'll again use the same thing here. The body is going to be the same. This dot name is equals to name. Similarly, this dot age is going to be equal to age. And now I'll use the same functions, but instead of attaching them to the prototype, all I can do is just create the function. So say name. I don't have to use the function keyword. I can just write it like this and type console.log this dot name. Similarly, this dot age. And now if I were to create a new person, I have to pass in name, and name could be anything. I'll call it John, age 35. Now John dot say age, and again John dot say name. Now if I were to save this, go back, open up the console, refresh, and you can see if I refresh this, we have John and 35. So as you can see, we are getting the same thing. But now if I were to console log John, you can see that it's exactly the same thing that we had earlier. Age and name are there, and the functions, including the constructor function, is attached to the prototype. So it's just a new way of declaring a class and using a class. It doesn't necessarily mean that that's the only way or that's even necessarily the right way. However, this is the way that many people use functions and classes, and we recommend that you take a look at that as well when you're trying to do it. Which one should you use? Well, the recommendation is that you use the newest features as soon as possible, because it may be possible that JavaScript or newer browsers drop support for the older version of code. However, that doesn't seem very likely, but it could be possible. So in order to avoid that, jump onto the latest version of code as long as it's supported with the supported in the majority of the browsers. And these features are supported, so you can take a look at those in whenever you want. All right, so now let's take a look at JavaScript and DOM. First, we'll understand what a DOM is. So DOM stands for Document Object Model. It is a tree-like structure which represents the HTML document and can be accessed and manipulated using JavaScript. So if you remember, when we were discussing the history of JavaScript, JavaScript was created in order to manipulate HTML pages. And the DOM is the way that it does that. The DOM, or the Document Object Model as it's called, is basically an interface through which JavaScript can interact with the HTML pages. This is implemented by the browser, and what you can do is use the methods on JavaScript so that they can execute the code and manipulate the DOM as you wish it to. Now, these DOM elements are arranged in a tree structure. Just as an HTML page is created with nodes nested inside each other, that's how the tree is formed. It's a hierarchical structure in which each node is either a child node, parent node, or a leaf node. So this is how the HTML document is structured, and then we take a look at the JavaScript. JavaScript can be used to perform different kinds of manipulations on the DOM. Let's take a look at them one by one. So using JavaScript, there are several kinds of operations that we can perform on a DOM element. First one is accessing the DOM elements. So depending on how you want to access the JavaScript DOM element, you can access it in several ways. We'll discuss them in the hands-on, but one of the ways is using an identifier. So if you're creating an HTML page and you want to access it in JavaScript, you can assign an ID to it. Similarly, you can assign a class to it as well. Just as you reference the documents or the elements in CSS, you can reference them in JavaScript as well. And you can use IDs and classes for that. There are other ways as well. You can get the name of, you can get the documents or the DOM elements using the tag names. So if you want all the forms on your entire HTML page, you can do so in JavaScript as well. And there are many other ways as well, which we'll discuss. Then comes adding DOM elements. So what happens is you can create your own DOM elements and then you can attach them to the HTML page as well. Suppose it's an empty page, you want to create a new DOM element. You can do so using the JavaScript's DOM API. What happens is, firstly, you get the DOM elements, you get some data, create a new DOM element, add data to it, and then we can attach it to the DOM. With that, we move on to manipulating the DOM element. Now, manipulating a DOM element is also quite easy. What you have to do there is basically you get the data and then you manipulate it. You get the DOM element, you change its style, change the text contents, you can change different kinds of things about it, and it will work exactly the same way. Manipulating the DOM elements involve you getting access to the DOM element, and then you making changes to it. So you can make changes such as change the order of the elements, remove an element, add an element, which we have already discussed, but also you can change the text content inside each of the HTML DOM nodes, and that works as well. Finally, you can take a look at removing the DOM elements. Removing the DOM elements might sound a little difficult to understand, but it's fairly easy. You get the DOM element, you get all the child elements of it, and you remove those child elements, and they will be gone forever. So they are removed from your screen, and then you no longer have access to them. So that's how you can create DOM elements. You can access DOM elements, you can add DOM elements, you can manipulate DOM elements, and you can remove them as well. These are a whole variety of operations that you could ever want to perform on a DOM element in the JavaScript ecosystem. But how do you do that? Well, let's take a look at the DOM operations, and here we can understand that.
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which event can be fired on a scrollable document element? A. Window. B. Scroll. C. Load. D. Unload. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The first things first, I will open up the page. I'll remove everything from here and I'll open up this code. Now here I can write the code that I want. So as you can see that the page is empty. Just for the sake of understanding, I'll create an unordered list item and I'll give it an ID of list. That's about it. First thing we have to understand is how do you get access to a DOM element, which is quite easy. You can just use document. Firstly, I need a variable name. So you get document dot get element by ID. This will only return one item because on an entire page, it is recommended that you only have one item with the ID assigned to it. So the ID that we had assigned to the list, unordered list, was list. Save this and we'll console log the list. Save this here, go back, open the console, refresh, and you get the unordered list here. It has nothing inside it thus far, that's why it looks like this. Another thing you can do is use class. You can get access to something using a class. So instead of this, I'll get class. But one thing you'll notice is get elements by class name. Save this, go back, refresh. This is an HTML collection. So as we have already discussed that when you are using classes, multiple elements can have the same class. However, IDs are unique. Each element should have its own ID. So this is where we use that. So if we have some element that is repeating on the screen, let's say you are creating an e-commerce application and that e-commerce application needs to show a list of products. So each individual product will have a class of product, and to get access to all those products in an array, you can use the document.getElements by class name. Also, if you don't want to use class names, let me just go back and use ID. You can also get elements by tag name, and the tag that we are using here is unordered list. Save this and log it to the console. Again, you get an HTML collection and you get a list like this. These are the properties of the list. This would look like, and this is the same thing. So this is how you can create an HTML collection by using the tag names. If there are multiple lists, you will get all of those here. Now that we know how to get access to those, another way you can do those is if you're familiar with CSS, you can use CSS like syntax to get access to a particular element. So you can use query selector, run query selector all. Inside query selector, you pass in the query. So I want access to AUL with an ID or list. Save this, go back, refresh, and I get access to this. Similarly, if this was a class, then all I have to do is an unordered list with a class of list. Go back, refresh again, and I get the same access, right? So this is how you can do that. Now query selector all is another method that will select all the elements of the list. So if I'm using class and I have two lists with the same class, I go back and refresh. Now I have a node list of 2. So I have 2 lists, both of the same class, and that match the parameter that I have passed in. So that's how you gain access to a list. Let me just clean this up a little bit so that we can take a look at other features as well. ID is list. So this is how you can gain access to it. Now how you can add items to it is what I'm going to show you. So to add item to a list, all you have to do is firstly you have to gain access to the list. I'll just gain access to the list using document.getElement by ID. Since we only have one list, I'll get access to that. Now I want to add a list item, li, to it. To do this, all I have to do is use this. So list item is equals to document.createElement. The element name is going to be li, and I added here. Now list item dot text content is going to be equal to list item 1. Save this, and now I want to add this to the list. So list dot append child, and I want the list item. I had named it correctly. Go back to the code, refresh, and if I take a look at the console, list item is not defined. Okay, this is because save this, go back, refresh, and now I have a list item. Similarly, if I want, I can create 5 list items using a for loop. It's going to be exactly the same thing. All I have to do is for variable I is equals to 0, I is less than 5, I plus plus. And now I will create a new list item whenever the code runs. Create a new list item plus I, and save this. Go back, refresh, and I have 0, 1, 2, 3, 4. So 5 items already attached to it. That's how you can create a list item. If you take a look at the HTML content, this is what it looks like. I open this up and this is what it looks like. Now, if I were to open up the source code, as you can see, this has an unordered list with no items added to it. This is why the JavaScript console is so useful. It tells you the current version of your HTML DOM. So as you can see, I have an unordered list. After the file is loaded, HTML is passed, JavaScript is executed, I get 4 more or 5 more items added to my unordered list. So that's how that works. So creating an item we have already discussed, appending the item we have discussed, and accessing the items is also something we have discussed. Now let's take a look at how you can delete an item. So I'll just create an unordered list 3 times. I'll call them list item 1, 2, 3. If you go back to the code, this is what it looks like. Now if I want access to the course, all I have to do, so last item is going to be document.get elements. Firstly, let's take a look at items. Get elements by tag name. We get all the list items here. If I were to log it to the console, this is what it would look like. Go back, and this is the collection. Now I want access to the last list item, so I can just go now I'll get an access to the item, and I want to remove it. Then I can just type item dot remove. Save this, go back, refresh, and this works. Now if I were to not remove this and go back and refresh, it will have the item here, and I can just do it here. So item dot remove, and now it's removed from the list. So that's how you can remove items, add items, manipulate items, and all of that. You can also manipulate the items by getting an access to item and item dot, and you can take a look at the text content. You can do several different things. So if I wanted to document dot create text node, I will add in some text here and new content, and I will just use item dot append child using document dot text. And if I use this, then new element is added into the item. Now if I want to, can very much easily change the text content to be equal to, but this won't add new content to it. It will just remove the old one and add this one. So if I go back and I refresh, and that's how you can manipulate the item. This is just scratching the surface. DOM manipulation goes way deep into it. You can also take a look at the styles of a particular class. You can take a look at the styles applied to it. You can change the styles on the fly. You can do a lot of different kinds of things using DOM manipulation. This is just barely scratching the surface, but this is to give you an idea of how you can add things, remove things, manipulate items, and create nodes on your own. However, doing this all on your own is going to be a little tricky and can lead to degraded performance. So if you want to use JavaScript to add items and remove items and track changes, React.js is a library that does that for you. So you can take a look at that as well. Now let's take a look at JavaScript events. So JavaScript allows us to use browser events to perform certain tasks when an event occurs in a browser. So there are two parts of an event system. Although JavaScript is a fundamentally event-driven system, you need to understand how to use these events in order to write code that works when the user performs certain actions. These actions could be when the user submits a form, when the when user clicks on a DOM element, when the user is moving their mouse, or whatever the reason might be. So the two parts of a JavaScript event system are events and handlers. So let's discuss them one by one. An event is basically a description of what has happened. So an event could be a click event, which basically means some element was clicked on. It could also be a focus event, which means some form field was focused on. It could be a submit event, which means some form was submitted, and so on and so forth. So these are the kinds of events that JavaScript HTML supports, and JavaScript can use these events in order to hook into these events and perform certain bits of code when these kinds of events happen. So for instance, when a user submits a form and you want to send that data to a web server by serializing it, HTML by default doesn't support it, but JavaScript does. So to do this, you need to firstly prevent the default behavior of submitting the form, then getting the data, and sending a request to a web server. Then processing the request and redirecting the user. All of that is done using JavaScript. Then comes event handlers. Handlers are functions that take care of the code that needs to be run when an event occurs. So we can assign several event handling functions onto a particular JavaScript event, and then when that event happens, all of these functions will be executed. Now let's take a look at a hands-on to understand how that works. We have the code here and we have this HTML page. First thing I'd like to do is I'd like to create a button here. The text click me, and I'll have an ID so that I can get access to it. A button. Save this. Now let's first get access to it using document.getElement by ID, and inside the ID I will type in the ID that I have just assigned, which is button. To do this, all I have to do is type in button dot on click. This means that whenever the button is clicked, use this function. Now I can use the function syntax, or I can use the arrow function syntax. It can expect an event, and now it doesn't have to return anything. All it has to do is console log clicked. I can also remove this. Save this, go back, refresh, open up the console, click here, and as you can see, it is written here. Now if I were to do it again and go back, refresh, and now if I click again, as you can see, the new handler is being executed. Now this might be a problem in case you are wondering how. Suppose I want to perform two different kinds of functions on the button when the button is clicked. The code that I want to execute is attached into different functions. To do this, I can just use button dot add event listener, and I can pass in the listener. Firstly, I'll type in the pass. I'll type in the event and then the handler. So this event is going to have console.log. Similarly, second. Now if I go back, refresh, click, as you can see, both of these get executed. You can also type in the, if I were to do it here, you can also get the event listeners here as well. All you can do is you can just add button dot add event listener, pass in the type. Let's say I want click, and I'd like to log it to the console, THIRD. Third, and now if I click, this works. Now you can pass in anonymous functions, although one way I would recommend is you create a function which will type in here and will write port. The reason why I would recommend doing this is just going to become apparent in a moment. I'll again take the button, add an event listener. It's going to be called click, and I'm going to add F to it, right? Now, one thing to notice is that if I click on the button now, all of these are executed. But if I want to unattach this event listener or remove this event listener, remove event listener, and this will take in the type, which is click event, and the target that I want to remove is this function. If I go back now and if I click it, as you can see, first, second, and third are executed. Now, this is something that you can't do in the previous versions. So if I had not assigned a variable named here, I would have no idea how to access the fourth event listener and remove it. This also prevents memory leaks. So if this button is destroyed from the memory, then the event listeners will also be destroyed. So that would be helpful there as well. So with that, we have understood how events work. These are not the only kinds of events. You can take a look at different kinds of events that you can take a look at. For instance, you can look at form submissions, checkbox selections, button clicks, which we have already taken a look at, mouse events, cursor events, touch events for mobile browsers, and many other kinds of events. So this is the general idea of how you can access them, add event listeners, remove event listeners, or if you just want one event listener attached, then you can use the on-click or other kinds of functions as well. All right, now let's take a look at asynchronous JavaScript. So in case you're not familiar with it, let's take a look at what asynchronous JavaScript means. So JavaScript allows us to write asynchronous code, which is executed in an asynchronous fashion. Asynchronous doesn't necessarily mean that it is parallel, but it does not block the main thread. JavaScript is a single-threaded language. The JavaScript being single-threaded means that you can't create new threads out of JavaScript. So in cases like this, the languages like Java, C++ have the capabilities of creating new threads, and then you can push some long-running tasks on those threads so that the main thread that is displaying the user interface and making other things happen can stay responsive and doesn't end up freezing up. But in JavaScript, you don't have this feature. On the other hand, we have something called an asynchronous runtime environment. What happens is when you have a long-running task, what you can do is you can push things out of JavaScript and into your browser's thread pool. So every browser has its own thread pool. You write some code and you say, okay, this code needs to be executed by the browser. It may take a long while. So take a look at the code, run it, and then send back the response. And once you are done, send back the response to me. And how you get the response back is what asynchronous programming is all about. So this is where asynchronous code comes into play. Now, to write asynchronous code, we have three ways of doing that. First is callback. A callback is basically a function that is passed into other function that will call your callback function and will pass in the result or an error if any occurs. So for instance, let's say that I want to perform some complicated computation. So I run this function. That function will move on to run into the browser thread pool, and it will run and perform all the computation. And as a parameter, I will pass in another function, which will be called. And when that function is called, that function will take in the results that the computation provides us and will execute it the way I want it to.
Okay guys, a quick info: if you're looking for an end-to-end training in JavaScript, Intellipaat provides a full stack web developer course which covers JavaScript and all the JavaScript frameworks you need to know. For more details, check out the description box.
So that's a callback. It has certain advantages such as being very easy to understand, not very difficult to read also, but then again, the problem that comes with callbacks is that the callbacks are a little complicated. You run into a problem called callback hell, in which you are nesting one callback into another callback into another callback into another callback, and this leads to a really complicated structure and makes your code really difficult to read. To overcome this, promises came along. Promises allow us to write asynchronous code as a series of operations where one operation manipulates the result of the previous operation. So the way it works is that, let's say I have some operations that I want to perform. Let's say I want to get the data from a server. So that requires certain things to happen. Firstly, I have to make the request, get the response. After I get the response back from the request, I need to parse the request, extract the information I want out of that request. All of these could take a bit of time. So if I want to compose this into a set of linear steps, I can do it using promises. Now, promises are great, but also they lead to certain problems. So in order to overcome those problems, we also came along with other kinds of things such as async await. The problem with promises was that chaining promises one after the other could be a little difficult, and understanding how promises were executed, especially when you have multiple execution paths, is a little difficult. Async await turns the asynchronous code into a synchronous code. So we can write asynchronous code just as we write synchronous code without using promises or callback, with just using the async and await keywords. And that was about it. Our language and our runtime will understand what exactly we're trying to accomplish, and it will take care of all of those things on its own. So with that, let's take a look at how we can perform asynchronous code on our own by taking a look at a hands-on. In this, I'll write the code in the file and then I will open up my console. Let me just refresh this. Okay, now let's take a look at this. So first thing we'll take a look at is callback. Let's take a look at all of these. First thing we'll take a look at is callback. Then we'll move on to take a look at a promise-based system. And then finally, we'll take a look at async await. First, let's take a look at the callbacks. So the best example of callback in JavaScript is the setTimeout function. SetTimeout basically takes in a handler and a timeout. So if I pass in the handler, it will basically be console.log, and the timeout is going to be, let's say, 5000. Now if I go back to my code, refresh, wait for 5 seconds, 1, 2, 3, 4, 5, and this is how it executes. So basically what happens is this code will get executed. It will wait for 5 seconds, and after 5 seconds it will run this code, whatever it may be. I've used arrow functions, but you can use any kind of function that you want here. So this is how you can do a callback. Basically, this is the long-running task. Let's say that this was, instead of setting a timeout, let's say that this was a network request. I sent some request to a network or some web API, got back the response, but it took 5 seconds for me to send the request and get back the response. So in cases like this, we can use a callback in which we say, okay, after you have performed the task, call this function, and this function will get the result. Once the result is gotten, all I want is to act on this result. So now I can just console log the result or whatever I want to do, but this is how it worked. So this is very easy to understand, but the problem here is this. Let's say I have a callback. I say, okay, fetch info, right? I will get the information here. Let's say that I have to use the timeout here. So fetch information, and I pass in a callback. Now here, let's say that I get it. The request takes 5 seconds, and after 5 seconds, I will call the callback function and pass in the result. The result is going to be an object with name of John. That's about it. So now if I want to save this, I'll save it. Go back to my code, run it. It says unexpected token on line number 18. Let's take a look at that. Oh yeah, I have to use the function keyword here. Now it works. Yeah, so fetch info, I will call in, I will take the function, and I will console log. This function will take in a result and will pass in result. So let's wait for 5 seconds, and after 5 seconds it should print. So it prints John. So suppose this is the response that I was getting back from a web server. So that's how I can do it. I can just pass in a function which will get the result passed into it somehow, and then I operate on those results. This works. However, if there were multiple phases of this, so let's say that I get this response, right? Let me just copy this and come here. So let's say I get this. After getting the result, I want to call another function and then pass in a callback. So let's say fetch more. I pass in the result, fetch more information about this, and then call this function. Now, as you can see, the code is really complicated. Now I have a function nested inside another function, and think about how it could go on. So that could be difficult. So in order to overcome this, we use promises. Now here is where I will be using the promise-based API that ships with browsers. Before, browsers supported promises. some people came along and created libraries that used promises on their own. So depending on how you wish to use them, you can either use some old school promise-based library, and you can take a look at those at your own pace. One of the most famous ones is Q and Bluebird. However, you can also create your own. So what I'll do is I'll make an actual network request. If you're connected to the internet, you can just use this. This is an open API that you can hit and get a response from. So I get the response. Right after I get the response, then what I want to do. So I will get the response and I want to convert this response to JSON. So I do that, and then finally I get the data, and I wish to console log the data. Save this, and I can go back and I refresh, and I guess it's an unexpected token at line number 24. Let me see. Yeah, now it should, and we get the response back. So this is what it looks like. Now this works, but suppose I wanted to make another request here. So I had to, after getting the data, I have to make another request using fetch and get the data and then pass it here. So it can get really complicated. It's not really difficult to think how it can go wrong, but it's really easy to understand right now. Another way is going to be async await. Now to do that, I will create a new function. So what I'll do is call it async. Then I'll call the function name. The name of the function is going to be fetch user info. Inside it, all I have to do is use the same thing that I had done earlier. Great thing about it is that async await works with promises. So what I'm doing is I'll write it exactly as I would write any other code. So I'm saying, okay, wait for this to finish. Once it's finished, return it into this. So we get the response. Then data is equals to response.json. Now again, I want you to wait for it to convert to JSON. And finally, console log the data. So as you can see, this is how you would write normally the code, just a bit of async and then await sprinkled around it. Refresh, fetch user info, call this, and you get the response back, and this is what it looks like. So this is the data that we got back, and we can use it whenever we wish to. Also, it says promise pending because if I were to do it, there is another way. I can just await it, and now it won't say promise pending. The reason why is because all async functions return a promise. If I don't return anything, it will automatically return a promise that is pending. It doesn't really matter, but you can take a look at this. If you want to really use it, so you can do it this way. Now, console.log await, and you can await the function, but you don't really need to do it here. So it works this way. Yeah, so this is how you can use async await, callbacks, and promises. Again, these things go really deep into it. You can use multiple promises, you can compose multiple promises and have them all run all at once. It's a really complicated web that we don't have time to navigate right now. You can take a look at the videos that are already available on our channel, or you can take a look at the Mozilla developers documentation. Either way, you can learn a lot about these things. All right, so now let's move on and see what else we have to learn. Now let's take a look at JavaScript and NodeJS. So NodeJS is a backend JavaScript environment that allows developers to run their JavaScript code outside the browser. If you want to build desktop applications, if you want to build web servers, if you want to build any kind of applications that works outside the sandbox of a browser, then you can use Node.js. Node.js basically is a JavaScript wrapper around a C++ API. So what happens is when you write some Node.js code, it gets converted into whenever you call a function in Node.js, the Node.js runtime environment will convert that function call into a C++ function call, and that C++ function call will then interact with the low-level operating system details such as memory allocation, deallocation, and other kinds of things. Node.js was created by Ryan Dahl. He was a Google engineer, and what he did was he took out the V8 compilation engine. V8 is a JavaScript interpreter or the JavaScript engine that is used in Google Chrome, and he took the code out of that and then created a Node.js platform in which you can write code and it will be executed outside the browser and it's allowed to run on the server. And you can also build servers, desktop applications, mobile applications, and many other kinds of things. Node.js is by far one of the most popular things in JavaScript right now, mainly because it allows us to expand this the subset of technologies that we can tackle using JavaScript. So with that, now let's take a look at a hands-on involving Node.js. So to do that, firstly, you'll have to download and install Node.js on your system. Go to nodejs.org/downloads or just go to nodejs.org and click on the downloads link here. You have two options here. You have LTS and current. The difference between the two is that the current version will be the latest version available for you to use. It will be, at the time of the recording, it's version 15.4. However, in the LTS mode, you get a slightly older version. In this case, it's 14.15.2. However, the thing that is important here is even though you have the older version, it's a version that will be supported by the Node.js community for a long time. So if you run into some issues, some bugs appear, new patches will be deployed to it. However, in the current version, if you were using version 15, you come into some issues, some bugs are there, you have to upgrade to a newer version. The newer version might not have the same feature set as the previous version. Maybe some API has changed and now you have to change the code. So only use the current version if you want to try out the latest features. For production, LTS is what is recommended. Now to download it, you can choose the Windows installer depending on the operating system that you have. I am on Windows, so I can download this. You can download Mac OS installer, or you can download the source code of the entire Node.js project and build it yourself. If you're on Linux, you can download the Linux binaries. They are available here as well. After doing that, you can just install it like any other software, and then you can get started. Now, if you want to use Node.js, first thing you have to make sure that it is installed and it's available in your command prompt. So open up your command prompt in any folder you like. Type node version. Press enter. The version 14.15.1 is the version that I have installed, and you also have to check npm version. We'll see in a bit what npm is and how it works.
Just a quick info, guys. Test your knowledge of JavaScript by answering this question. Which of the following is not considered as an error in JavaScript? A. Syntax error. B. Missing of semicolons. C. Division of 0. D. Missing of brackets. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
npm stands for Node Package Manager. It's similar to pip, Maven, or any other package manager in other languages. The version that I have installed is 6.14.9. Also, you have to check npx version. Although if you have installed Node.js and it's showing you the version to be about 12, you don't have to worry about checking npm and npx because they are all installed all at the same time, unless you run into some error. However, it's good to check whether or not you have everything installed correctly. Also make sure that the version of npm and npx match because they both work in tandem. I'll clear the screen and I'll show you how it works here. Now, I have a file named index.js. If I were to go back, take a look at the directory, I only have the same file here. Now if I want to run this file, I can type node space index.js. Since there's nothing here, I can't run this file, or I have run this file but there are no instructions in it, so Node.js just exits. Also, if you want to perform some small bit of code, you can just write node, press enter, and it will open up a terminal session for you in which you can write the Node.js code you want to run. Now again, window is not something that is available, global is. The reason for this is because it is not a browser environment. So things like clear timeout and all of set timeout, all the features that are available in window in browser environments will not be available here because window is not here. So global is what the object is called. After this, what you can do is write some code using Node.js. Simply JavaScript code that uses console log, and here the console is this terminal, so it will print it here. In browsers, it was the browser console. So we print hello. You can also type in any other browser code that we want to write. So x is equals to 45. Now x is equals to 4 and we get an error because constant variables cannot be reassigned. So that's it. Let me just exit out of it. So this is how you can run Node.js in terminal session. But what if you want to create a project where you write the code and all of those code files are combined together and they work with each other? In cases like this, firstly you have to create a Node.js file. We'll see how to run a single script. If you're creating a project, the setup is a little different, and we'll take a look at that as well. So here what I'm going to do is I'm going to write console.log and I'll write hello. I save this, go back to my code, and I type node space index.js, and here the file gets executed. And then after executing the file, it exits out. Any JavaScript code is valid here as long as you're not referencing the browser specific code, such as document.get elements by ID or window or history or things like that. Any other JavaScript code is valid here. Node.js ships with a few modules on its own so that you can use things like file manipulation, file handling, HTTP requests, and so on. You can read about them at your own pace. Now, let's say I want to create a project in which multiple files are there and I want to be able to share this project with other people. To do this, first thing you have to do is you have to initialize an empty Node.js project in a folder. I'm in a folder named Node in my E directory, in my E drive. To initialize a project, I have to write npm init, and it will ask you a series of questions. Now, I don't want to have to answer these questions, so I'll just write --y. Press enter. All of the default values are put for the answers. The questions they would have asked would have been the name of the project, the version, description, and so on. So doing this ends up creating a package.json file. This is what specifies a Node.js project. So any directory that has this file in this format is a Node.js project, or is a valid Node.js project. Now, the reason why npm is used is so that we can use the code created by other developers. We can import libraries to perform tasks without writing the code for them. Suppose I want to build a web application. For that, I want to import a web framework such as Express.js. If you've ever worked with Node.js, Express.js is quite a popular web framework. Let me show you how you can use it here. To do this, type npm install and make sure you're in the same project where you have initialized a package directory. If you have not initialized an empty project, then this command might throw an error or might install something but could lead to some issues. Make sure that you have done that. Now npm install express, press enter. This will install a single package, however multiple packages can be installed. It won't take a lot of time because it's a really small package. After the package gets installed, we open up the same folder and the structure has changed. Now we have a package-lock.json and a node modules folder. The node modules folder contains all the modules that are required for the package that we have installed and the package itself. So the package was called Express.js, right? If you take a look at Express.js, it's here and all the code in it is available here as well. So if you want to take a look at how it's implemented, you can do so here as well. Now that that's done, let us take a look at how we can use it in our index.js file. So I will just use it here. I'll import Express. In Node.js, you use the require keyword, although the import keyword is also something that is supported nowadays. But you should, just for the sake of clarity, use require right now. Now that we have imported Express, I'll create an application of Express.js. Here I can pass some configuration options. I don't want to right now, but I can. App.get. If I get anything for this, I will just write request and response and a response.send. Hello. Save this, and now I have to start the file. So app.listen on port 3000, and after you are done listening, type in listening on port 3000. Save this. Go back to our code and type in node space index.js. I press enter. It shows me that it's listening on port 3000. That means that I can go to my folder localhost 3000, press enter, and this is the response that I get. This is a local web server that is running, and now I can create my HTML files, templates, whatever. So this is how it works. Again, what happens is The reason why we did all of this is because let's say that now I want to share my code. So what I can do is I can just share this package.json and index.js file. These two files will do it entirely for me. So now when a person opens up this, they will see that, okay, this project depends on Express. And they don't have to install it manually themselves. Just open up the folder where they have these two code files and type npm install. The node package manager will take a look at all the packages your project depends upon. In our case, it's just Express.js, and it will install everything that is listed in this automatically. So you don't have to dispatch the commands on your own. And then this node modules and package.json file is created automatically, and then you can use it. So this is how Node.js works in a nutshell. We are barely scratching the surface here because Node.js is quite deep and it takes a lot of time to understand. So this is just the beginning, and you can take a look at more packages and more ways of doing things in Node.js if you're interested. Now let's take a look at how we can build an application in JavaScript using the technologies and topics that we have heard so far. And we'll try and use as many of these technologies and features that we have learned about JavaScript so far into one single small project. We'll try and build a to-do list application. Now to do that, you can follow along with me. All you need is just a browser, an HTML file, a text editor in which you have opened both the HTML file that is got this code and it has a reference to a script file, and this is the script file here. Just to make sure everything's working correctly, I'll just type in console.log and I'll just log hello. Save this, go back, refresh, and take a look at the console now. If it has the word hello, that means everything's wired up correctly. And it does, so everything's working fine. Now it's time for us to build our application. Now, the application that we're trying to build is a to-do list application. Basically, what should happen is that there should be a form in which the user can enter some text and a button to add that text into the browser's window. So what to do is, firstly, we have to create a form. Here we'll create a form using HTML. The action I can just leave as hash because I don't want to submit this form anywhere. This is something that the browser needs to take care of on its own. The input of type text ID is going to be description because this is going to be the description of the to-do. And finally, what we have to do is create an input of type submit. Save this. Everything's working thus far. If we go back and if we refresh, we have these two things. Now I'll write something for the placeholder so that when the person is taking a look at this, they can understand. The placeholder text is going to be to-do description. Save this, go back, refresh here, and it's showing us the to-do description here. Now if I add something here, let's say to-do submit it, firstly you can see that it refreshes completely. We need to stop that, and nothing happens here as well. So how to deal with this? Basic formula is, firstly we have to open script.js. First thing we have to do is gain access to the DOM nodes that we want to manipulate. To do this, first thing I'll do is I'll also create an horizontal rule. Then I'll create an h3 that says to-dos, and then I'll create an unordered list with the ID of list, and this is what will house our entire to-do list application. Now again, if I go back and if I refresh, this is what it looks like. So add the to-dos here and they will show up here. You can obviously style things up using CSS, but right now we won't be doing that. So save this, go back to your code, and now here we'll write the code. First thing I have to do is I have to gain access to the form. Now I can gain access to the form quite easily. So I'll create an ID here and call it submit, or I can call it FORM form. To gain access to that, all I have to do is type form, and since we are in the browser environment, I can type in document.getElement by ID. The ID that we assigned to the form was called form. So now if I save this, go back, refresh, log into my console. And since it's on the browser, I can just type in form, press enter, and this is the form that we get. This is exactly the form we want access to. Now, when the form is submitted, I want to do something. So form dot on submit. This is going to take in a function. I'm just going to use an arrow function here, but you can use the normal functions as well if you wish. First thing I have to do is prevent the default behavior, which is it submits the form and it reloads the page. I don't want that to happen. Now, what I'll do is I'll console log the event just to show you what it actually looks like. So if I go back, refresh, add to do here, click on submit, this is what we get. This is a submit event. It has a load of properties that we can take a look at: source element, target, timestamp, type, submitter. These are the kinds of events that we get access to. These are constructed by JavaScript itself. We don't have to worry about how that event happens, but we just want to access it and then make sure that everything works. So we get that it tells us, okay, what made it submit, and this is what made it submit, the input submit button. The source element was the form and many other kinds of things. You can take a look at how the HTML path is there. So we have window on which there's a document, on which there's an HTML tag, inside it there's a body tag, inside it there's a form tag with the ID of form. This is what we have right now. And these are all the other properties that you can take a look at if you wish to. Now what we want to do is when the form is submitted, after this, I also want access to input box. So document dot get element by ID. I'll use the ID of input. As far as I'm aware, I've not assigned the ID yet, so I'll go back to the code, and the input box has an ID of description. I can just call this input. That will work as well. Now, when we get this, what I want is, firstly I want to extract the description to be e dot target, or not the target, sorry, the input text dot text font. Save this, console log the description, save this, go back, refresh, again we'll add a to do, submit it, and we don't get anything. Now if we take a look at the input here, go back, refresh, and submit it, you can take a look at how that shows up. So if I were to go back and say document get element by ID, and if I were to get the input, this is what it would look like, which is exactly the same. But if I then take a look at the properties that are available to me, you can also take a look at that here, or you can take a look at that at your code. So what we want, we have text, content, class, child, or you can also take a look at the node value property. There are many properties that you can take a look at. You can also take a look at the inner text or inner HTML, whichever one you wish to choose. There are many properties that are available for you. In order to gain access to it, you have to use the JavaScript files that you are using. So to gain access to the text inside an input in using JavaScript, the thing that you have to do is use the text property. So input dot inner text. Let's see if that works. So we go back, refresh, to do, submit. It's still not working. So let's take a look at that. And we can also take a look at the value. So now we are getting the output that we want. So here all we have to do is just type it here. After we get the value and the description, we want to add this to our list. again, we can do this here by getting access to the list. Get element by ID. We named it list. Save this. Here's the list that we have. After getting access to the list, we can do it here, but I think we can create a function here as well. So I'll call it add to list. Inside the list, I have to just pass in the description, and that's about it. Now I can create a function named add to list. This will take in a description. Now what it will do is, firstly, it will create a list item. Document dot create element. This is what we learned in our DOM manipulation text. And here we want to append a child, and for that appending we need document dot create text node, and that would be of type description. After attaching this, all we have to do is use the list and append children element of the list item, and that's about all we have to do that. So if I go back now, refresh this, do submit, and now a new item is added here. So that's how you can do that. It's not very difficult to do. You can do it quite easily. That's the to-do list that you can build. You can add more items to it. There are many other features that you can implement, such as for it to interact with the web server and many other kinds of things that you wish to do. One cool thing that you can do now is, since this is implementing it here, we can just take a look at this. One problem that you might face is that once you're done with this, firstly, this box is not clearing. Secondly, if I click submit, it adds an empty one as well. So here's what we can do. After adding it to the list, we use input dot value to be nothing. That's the first thing. The second thing that we want to do is we want to, after extracting the value, check if value dot length is 0. Then we just return. Save this, go back, refresh. If I click submit, we get an error, value is not defined. Okay, not value, it's description. Go back, refresh, submit, and now as you can see, we are getting no errors here. There is no input, and if I add it, as you can see, this input gets cleared and new thing is added here. Now again, you can pretty this up using CSS. You can add more data, you can clear up the code a bit, you can wrap it all inside a function and execute that function, whatever you wish to do. Depends on how you think things should go. This is just one way of solving the problem. The reason why we created a function to do this is because this is a chunk of code that is always going to be executed the same. We always are going to create an element, always are going to create a text node appended to the element, and then append that to the list. So since it's always going to happen, we're doing it here. Now the reason why we executed these at the top and not in the functions is because we only want to do DOM accesses once, because this could get really performance inducive. So we want to be able to do it once and then gain access to them and then not lose the access, because querying the entire DOM can take a lot of time. So that's why we do this. Now if you have some other features that you'd like to implement, take this as the starter code and you can implement it there as well. Features such as taking the to-do list application and adding a checkbox. So when the user is done with the to-do, he will click on the checkbox and that to-do will either get deleted or that to-do will have a strike through it. And there's a button right next to it that the user can click to delete the completed to-dos. Depends on how you wish to do this, completely up to you, but that's how you can do it. This is the basics of how you can do it. Also, if you want to save this in the local storage, you can do a lot of things with it.
Okay guys, a quick info: if you're looking for an end-to-end training in JavaScript, Intellipaat provides a full stack web developer course which covers JavaScript and all the JavaScript frameworks you need to know. For more details, check out the description box. Okay guys, that brings us to the end of this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below. And also if you want us to let us know to take a different topic or a concept in the next video, please leave that down also and we'll note it and do it in the near future. So thank you, meet you in another session.